Morning, everyone. Morning, good morning. I hope you had a great time yesterday. Is everyone there? Hello. This one. Hi. Hello, guys. Hello. Anyone there? There. Hi. Good morning. Good morning. Once again, I welcome you all to our second day of our second international conference on emerging trends in engineering and technology, also as the ICETET 2021. And I may now call on our first eminent keynote speaker. Her expertise in circular economy policy, business strategy and business model, education, training, entrepreneurship, ecosystem building, academic track record in education, training, on innovation and entrepreneurship for sustainability and SDGs business track record in strategic partnership and business development in sectors including solar energy, advanced materials, advanced electronics, healthcare and agriculture, food technology analysis, and market assessment in emerging technologies, including advanced robotics, AI, data science, nanotechnology, additive manufacturing, and others. International business development and strategic marketing for companies to expand strategic partnerships and accessing available resources in Asia, including funding, infrastructures, innovation, and human resources. R&D project management and investment advisory. Let us welcome Dr. Lerwin Liu.
Hi everyone.
Hello, hi.
Hi there. Jojo.
Yes.
Can you tell me again how much time you have allocated for me?
Well, it's if you can
30 minutes.
Yeah, you can if you could.
Because I want to make it a bit interactive. So everyone, hi everyone here. Are you ready for an interactive session? Hello, I need to hear you guys. You don't need to turn on your camera if you don't want to save bandwidth, but you can unmute yourself so I can hear you. Can I hear you? Okay. Now. Okay, I can hear people. Can I assume that most of you are familiar with circular economy? I can't hear very well.
Yes.
Is there Jojo, is there a way for people to raise their hands or something?
Yeah, I suppose there's a reaction that you can raise your hand just right below there, the buttons in Zoom. Yeah, we can raise our hands there.
Can you raise your hand if you are familiar with circular economy? Raise your hand. Can I see any hands? Nothing? No hands? Not familiar? Okay, so I assume, then let me do a small introduction, okay? Are you guys ready? I can't hear anybody.
Yes, madam.
Yes.
Are you guys ready? Are you ready?
Yes.
All right. So I just want to maybe, let's see, a few minutes to give a quick introduction. Let me see, you need to share screen, right?
Yes, please go ahead.
Okay, share screen. I want to give you guys a sort of context on why we are talking about circular economy now and why it all matters to all of us. Okay. So why we're talking about circular economy now? Anybody can give me an answer? Maybe? Unmute yourself. Say something. So first of all, if you don't say anything, let me just share my perspective. Often, in my mind, when I go to shopping, go for shopping, and I pick up an item, I usually wonder where it comes from, right? Where is it from, and how did it get here? What's it made of? How it was produced? So this is kind of questions usually is in my mind. I don't know whether it's in your mind, but it's in my mind. So I always question why, what, how, and then that actually links to a global supply chain issue, right? Now, if you follow a product of the life cycle of a product, now I will use textile as an example because textile, we wear clothes every day. And I think it's something that you can relate to. And so any product today, because we're in a very globalized world, and the production of a product usually is very decentralized. And it involves from extraction of natural resources, to process the material, to product design, to manufacturing, to distribution and consumption to us, and then we dispose it. So that's kind of a linear economy today. And then there's also waste collection, export for recycling and recovery for many decades also. So let me just give you a little perspective as an example. I use textile as an example. And now textile, say a cotton t-shirt. So imagine I'm wearing a cotton shirt, yeah? And so first of all, I want to understand who grows the cotton. So typically, I think India grows cotton as well. India, China, America, and Brazil. And then it gets processed, right? You harvest the cotton, you spin the fiber, and then you produce the clothing. And so this part of the world is a bit exaggerated here, but mainly India and China produce the yarn and fabric, and some in North America. And now when it comes to producing clothes, a lot of the big brands from all over the world, from Europe, North America, from Australia, send their design to actually mainly China. China produced probably over 70–80% of world's fashion goods, yeah. And then after the clothes being produced, and it gets shipped to the rest of the world for consumption. Now, then after you consume your goods, clothes and plastic and many so-called waste, is actually the last more than 20 years, actually, the waste is shipped to China for processing. But everything has changed since January 2018, when China enacted the national soil policy to ban 25 categories of waste, including textile, plastic, and unsorted paper, and more. So then, now we have to deal with our own waste, which means now we have to close the loop locally. And that's actually why now in almost every country in the world is now trying to figure out how to practice circular economy, how to transition the economy towards circularity. So that's sort of a little context there. And so now, of course, how do we do that? The first thing we need to do is to reduce amount of consumption, because reduce consumption and you reduce waste. Then there's a 6R that a lot of people are talking about: reuse, repair, recover, refurbish, remanufacture, and recycle. So I can elaborate on that using my life cycle value chain analysis later to present you opportunities for innovation, opportunity for business, opportunity for entrepreneurship. And so, of course, the business has to change, because now if you want to reduce waste, you want to extend your life, the life of the product as long as possible, and also to take the responsibility of the end of life of a product. And there's a emerging service model and a rental model, and also reselling business emerging. And of course, to reduce waste, we have to design our product in such a way that it can be repaired easily, refurbished and manufactured easily, and recycling for lower cost of recycling as well. So there's a lot of opportunities there for design. But to do all that, to make all that happen, policy regulation is critical. We need top-down policy to drive new businesses with circular businesses. And of course, actually, in my opinion, most importantly, consumer behavior has to change, because you and I as consumers, how we consume, what we consume, how much we consume matters. Okay, so that's actually something that I have been advocating and also practicing on my own personally, how to consume sustainably, that we can also influence other consumers to consume sustainably. That's how we can actually change our economy. And meanwhile, we also need to develop technology. And a lot of you from academic, you are working on a lot of material innovation, and you work on waste management, and technology is critical in driving to make waste management more cost effective, and to create new materials from waste, and add on functionality to make also your product more sustainable, more durable. You need new materials. A lot of material innovation is needed in driving more sustainable and circular products. And of course, we need money to do a lot of things. We need money to do research. We need money to start a new business. Financing is critical, and we need money to fund our research, right? And so financing from government, from private sector, I call it public-private partnership, is critical in driving this forward as well. So now I'm actually involved in building the so-called global circular economy accelerator that could drive a global circular economy transformation through facilitating solutions and partnerships. And we create a platform for promoting leadership and for building partnerships. So I hope you can join me in our platform and participate in our platform, and together we could make this circular economy happen very quickly. And so and of course join our knowledge hub. And so knowledge is power, and without knowledge we won't know how to make our transition and how to change our behavior, how to change our business. Yeah. So that's my quick introduction. Now I can deep dive into a lot of topics, but I want to pause for a while, okay, and to see your feedback and your reaction to it. Any questions so far?
Well, not really a question, but just a reaction. Like, it's really difficult for that kind of the challenge there is just the discipline, personal discipline of us consumers. This is really, really difficult.
Yes, I empathize, because I have the same issue. It took me quite a long time to change my own behavior. For example, I love buying clothes, right? When I lived in Tokyo, I literally bought one piece of something, clothing, something, fashion item every week, because I took a train. Every day I took a train, at a subway station, and there's a beautiful boutique shop, and every day they have sale.
On the way.
And Tokyo is,
yeah.
tourism. So I just couldn't. It became an addiction of buying things. So it took me a while. That was 20 years ago, more than 20 years ago. And it took me a while. Now I'm going zero waste organic. Like all my organic waste has now gone to my compost, including my cat litter. I use pine wood for my cat litter. Everything goes to my compost, and I have a garden. And I grow vegetables, and I grow herbs. I grow plants with my compost. So I go zero waste and I reuse all my plastic. If I don't have, I try not to use plastic, but sometimes you can't help it because you buy food from the supermarket, it's all packed in plastic bags. So I use them as much as possible. In Thailand, single-use plastic bag is being recycled into making new plastic goods like rubbish bins or a plastic container for plants, etc. So actually, I collect those. I wash and collect those plastic that cannot be reused anymore, and send it to the collection point where the company I know who will recycle these plastics. So I'm trying. It took me a long time to do this.
Yeah, it's a really when I think of it, it's really difficult personally, as it's inspiring that you are already in the process. Now, us thinking me, yeah, thinking on how to start, because although outside, like in our here in the Philippines, it's already implemented in the malls that you use those eco bags and paper bags for
Yes.
for your groceries.
Yes.
Now, I think that's we start from there, but inside the house, we still on that on that situation that you still use all those things, plastics and everything, and throw it.
So
Yeah,
I
we
think one thing that I'm trying to discipline myself every day and every evening. So I have a backpack. So I carry a backpack with me, okay, every day, wherever I go. This is my life here. I have my passport, my water bottle, okay, and I also have a set of shopping. So this is my shopping bag. Inside my shopping bag is a golf carton. I have a container for food when I go buy takeaway.
Oh yeah.
Usable for my quarantine, and I have another reusable plastic bag in case I have to buy anything wet. I put it in. So every day in the evening, after I'm done with dinner, I make sure I pack everything inside my bag. So the next morning when I rush, I won't forget. So this has been a habit for me. So to make sure that sometimes I do forget, occasionally I do forget. Most of the time I have it with me, and so I don't have to use any container when I buy food or use any other package in a supermarket or in a convenience store. And of course, I always have this water bottle with me for coffee and tea. I have my own. So this is a little habit that we can all do, right? So as a consumer, we gotta act.
Yeah.
I mean, I'm an advocate. If I only talk about it and I don't practice, I bullshit, right? I can't move. I can't really change. At first,
True. Especially if you
myself. Right?
True, especially if you can encounter those curious audiences that ask questions, and if you don't experience it yourself, it's difficult to interact with them. Yeah, true. Thank you for that, and I think I would start on planning my schedule tomorrow and prepare the things that I need, and also research on those companies here where I can get those reusable things like the bags and the containers for the food. Well, I already have my water bottle now. So yeah, thank you so much for that.
Yes. So now I can go into a bit technical discussion now. Before
Please
I
go ahead.
Can I get some feedback from the audience, please? How would you like me to? Do you have any questions? Do you want me to talk about anything in specific that you may be interested in?
Hello.
Please.
Yes, sir. Yes, go ahead.
Question. Hello.
Yes, go ahead.
Regarding circular, you're talking about circular economy. Okay.
Yes.
Your topic. Okay. How it is related to the sustainable supply chain, or we are calling as a green supply chain?
Okay. Very good. Excellent. That's what I'm going to talk about next.
Yeah.
Yeah. Okay.
How do you correlate?
Excellent. So are you at business school?
Pardon, madam. Hello.
Are you at business school?
Yes. She was asking, sir, if you are in business school.
No, I'm not in business school, but being a faculty of mechanical engineering, I'm interested in that topic, so I'm asking.
Okay. All right, let me run through the supply chain and business model, okay? I have different versions. This one, let me go slowly. Okay, let me share my screen again. Excellent. Thank you for your question. Excellent.
Go ahead, please.
Excellent. All right. So now, guys, if you want me to talk about anything, you got to speak up so I can focus and customize to your needs, okay? Can you guys see my screen?
Yes.
Okay, first of all, I'd like to get everyone to develop a life cycle thinking mindset, okay? Now, life cycle thinking mindset is pretty straightforward, life cycle, right? Really understanding where things come from the very beginning, natural resources, all the way to the end product and the end of life of a product you consume. Now, this framework, we co-developed this with my colleague Mustak in the UN, UNEP in Bangkok. So we follow the three principles when we design the circular economy framework: improve resource efficiency, reduce negative environmental impact, and minimize waste. So now we know that everything comes from nature, yeah? So everything we need to produce come from nature. It doesn't matter whether it's agricultural product, rice that we eat every day, or cell phone that we use every day. Yeah, we eat and use, huh? So if you have any questions, we can go into details on that, but I just want a generic term for discussion right now. Now, in that process of extraction, so we need to manage that. Often it's not managed and it's become pollution to our land. Then after you have extracted your lithium, for example, and then you go into material processing, yeah? Then you produce components like battery cells. Then you produce a module, battery module, and finally you have a battery system for your phone, for your EV, for your energy storage power bank, for example, power wall, for example, for your renewables solar farm, solar energy farm, for example, yeah. And then again, in every process in the production, there's waste generated. All kinds of waste, could be gas, could be liquid, and then of course at the end we consume the product, and after we consume the product, it become also waste often, yeah, because so that's the problem of today. Now in the consumer, this consumer can actually do a lot of stuff over here. We can reduce, we can reuse, or we can refuse first. Refuse stuff that we don't need. We reduce the stuff that we don't have to. For example, eat less. For example, right? Reduce, and repair some reuse product, like the way I reuse my plastic bag. And repair if you can. I often repair my own clothes, my bags. If it's broken, I repair them. Yeah. So we could extend the life of the product we use, or not reduce consumption by our behavior, and that will trigger all the way to the production and trigger our impact to the natural resources, reduce natural resources. So everything reduced together. Yeah. And now with the sustainable waste management, there's six R that I mentioned earlier. Let me elaborate a bit more here. And so here, this is end of life, and so we add a distribution in here. So just to elaborate a bit more on the supply chain. Now, for those of you who are engineers and researchers, yeah, you have done a lot of research in this process. For example, if you do material research, if you do, say, if you're an electronic engineer, you may design a new electronic devices, IoT systems, or new energy systems. You're adding value in this process when you go in this way, yeah. And until it reaches us, so consumer will pay a lot of money for a smartphone, $100,000 for iPhone, for example. And the value add is in this whole engineering process. But of course, in the distribution side, often a lot of profit is being made here. For example, the cost of the actual cost, material cost or hardware cost of an iPhone is probably a couple of $100, but you pay $1,000. So who earns the profit? over here, right? A lot of profit, and the brand, right? And so the value add is here, is in terms of the engineering value as well as the commercial value, or the perceived value. But then after you use it, value lost. So, for example, as you can buy a refurbished one, but it's a lot cheaper. So it's considered value lost. Now, how do we increase value? So it's the I should say end of use, not end of life here. We have to change this a bit. So the conventional supply chain, we have mining industry, manufacturing industry, production and product distribution and service industry, that again, like I said, adding value. Now, to develop circular economy, we need to close the loop. So the end of use, not end of life, end of use can be added value by reuse, repair, refurbish. So you can develop a new sector called reselling a sector. I'm sure in India there are plenty, but that needs to grow. Yeah, there's a plenty of growth opportunities by also changing the consumer behavior. If consumers, like people like me, I'm happy to buy refurbished products. So if I convince more people to buy refurbished products, and this industry will grow. And then this industry will go, we reduce, yeah? So you just shift the growth from here to here, yeah? The green industries, the green side. Now, by adding value back to the production side. So here you're adding value to the distribution. So close the loop like this. Now, if we close the loop in this way, keeping in mind that we keep this out of sight, yeah? So we try not to damage our planet Earth any longer or reduce the suffering of our planet by closing the loop here through remanufacturing, recovery, and recycle. So an entire recycling industry right here is yet to grow, yeah. And so you can go into details on, for example, remanufacturing goes to component, recycling, recovery goes to material, and refurbish goes to component module, and repair goes to system. So you can map each of these R's into each of these value chain here. Yeah. So now, of course, we also evolve towards from ownership to service. So because at the end of the day, as a consumer, we use the product, we don't necessarily have to own the product, right? Because you provide a function that a consumer needs, not necessarily ownership. So, and in that way, producer can take more responsibility and reduce, and consumer can reduce waste. So that's a way to move forward. So, okay, I can elaborate a bit more in examples of different sectors, but I want to pause for a while here. And, okay, just pause for a while. And does that answer your question? Do you need more clarity in the supply chain and business model?
Hello.
Yes,
okay,
hi.
I got the answer, madam.
Sorry?
I got the answer when I go through this presentation, the last one, that
Yes.
how that, because I'm also talking about recycling of the product. Na?
Yes.
So when it is to be recycled, that waste could be going to generate some sort of money, some sort of amount, and that is related to circular economy. If I am correct, that what you want to discuss in the next half an hour, that is related to the waste is having some value, needs to be utilized. Is it correct? Hello.
The waste, I didn't get. I didn't get your question. Waste value.
I'm talking about the sustainable supply chain.
Yes.
Sustainable is once again related to minimum use of natural resources.
That's right. Yes.
Okay, and that is related to, once again, whatever we say, it's a waste. Actually, waste can be recycled, reused,
right,
add to some value. So that I want to know that how it improves or how it supports to the circular economy. That is my question. But I got the answer through your presentation. Last slide, I got it. That how we can help it. Huh?
Yeah. So often in the linear economy, I think in India there are a lot of tradition in practicing converting waste, or we call it cold waste. Actually, they're not waste; they're just end of use, right? To value. No, I grew up in China when I was a teenager. I lived in a zero waste world. Nothing is wasted. And we have very limited resources at that time because China was closed in the 70s and 80s, early 80s. And like we had 2 pairs of clothes, 2 pairs of shoes I had. One is jogging, the other one is for easy walking. And only maybe 5, no more than 5 sets of clothes that I can wear. So we're very limited. And if end of use, like any feather from the birds or chicken or any used shoes is being collected, there's a guy coming in on a regular basis to collect all the waste, and even the and there's also a recycling shop everywhere. Where when I was a kid, I remember I actually go to the construction site and I collected broken glass and waste paper, those paper that you put where you put the cement in. I collect all this and I sell it to the recycler. That's my pocket money. So so when I was a kid, I never saw waste. In my opinion, everything has value because I can get money out of those garbage that's on site. Yeah. So it's really a mindset shift in the way we see things, and also I'm sure if you from, like, I have experience growing vegetables. My family, my father's family, my grandmother was a farmer. So as a farmer, I often went to the village when I was a kid and staying with my grandmother, and I can see everything is used. The pig, the waste of the pig, manure of the pig is being collected and fertilized the farmland. And there was no waste in the countryside at that time, but there was no plastic packaging either. So we did not grow up with packaging. And when we went to the market, the free market, to buy vegetables were bundled together with rice straws, natural material. So we lived in the world, we lived in actually almost packaging free world. And I always had my own food container and everything reusable, yeah? So we had reusable containers, there was no single-use plastic. So it is a lifestyle that's changed because of plastic, the cheap plastic come to the market, and it's making life convenient for everybody. So now our behavior, consumer behavior, is all about convenience. But how can we go back to where I was when I was a teenager? Is it possible? I think it's possible. We just have to make that change. I think, is the change worth it? Yes, because we have to reduce the CO2. We have to combat climate change. We have to clean up our country, our land. We don't have a choice because it's full, so much dirt around us, so much garbage around us. It's not nice to live a home full of garbage, right? So I think I would urge everyone to start thinking how you could do a little bit, just like for me, just to remember to bring this. How difficult it is. It's not difficult. And just remember to bring this back in your in your backpack. Maybe, just pack everything in 1 minute. It's just 1 minute a day to think about how we can do something for our planet. And then if our planet is better, our people's life is better. Now, as a researcher, how can we, now that we have so much garbage on our planet, the urgency for our researcher today is 2 things. One, how can we use our technology innovation to turn all this garbage into something that is sellable and to compete with today's virgin materials? This is an innovation that we need. I urge every researcher to think about how you can change a research topic, how you could put that as a priority to convert all these different kinds of waste into something valuable and create economic impact. And second, how can you create new materials, or how can you make your material more sustainable, last longer, and so that the product that we use made out from the material that you invented can last longer, and it will not break, it not create microplastic, and for example. So, and there are so many opportunities that we could really tap into if we start focusing on our purpose. I think at the end, I found my purpose. I was advocating nanotechnology for almost 20 years. I thought technology would change the world, but actually, I think we need much more than technology to change the world. I think first we have to change our mind, our behavior, and make the right choice for our consumption. And then we can, as a professional, we can prioritize our research area to make a difference. So it doesn't matter if you're a data scientist, for example, there's so many opportunities you can also work on. Can you imagine if you digitize, you can provide information, because right now we don't have information. How much waste do we have? Do we generated? And also to have data about our behavior as well. So if I tell you that you had created 1,000 kilograms of waste every year, and if I show you the data how you create those waste, then you will start realizing, oh my God, I can actually change this to reduce this waste. I can change my behavior in this way to reduce waste. It's like energy consumption, right? You have smart meter. The aircon is broken, or my fridge is not efficient, or I should have switched off this and that light or that power to save electricity because not necessary. So once you can understand, of course, if we have self-awareness, then we don't need the data to guide us. We just need more self-aware. I find doing yoga is really powerful. And so if we lack self-awareness, then we need to show people the data. So it's you either use meditation, becoming more mentally aware of your behavior and your consumption, or if somebody else, get the data to guide you moving forward, to guide others to move forward. So there's so much to do as researchers and academic and education, of course. Education, if you're an educator, how can you use the information, use your knowledge to inspire others? Because knowledge is power, right? Without knowledge, if I don't know that our plastic is all over the ocean, or our plastic is actually killing the whales, if I don't know this knowledge, if I don't have these, or e-waste is now poisoning a village in China or India, if I don't have this information, I don't feel the impact of my waste. I had the life-changing experience about 7 years ago when I read a magazine called National Geographic on a Singapore airline. Second is e-waste and poisoning people in China and Africa and India. So that changed my life. So knowledge is how changed my life. So share your knowledge. Any other questions? Is there any other topic you want me to cover?
Oh.
All right. I think I think I've passed the half an hour already, Jojo. We can let the next speaker speak. If anyone wants to keep in touch, let me type my email. Just feel free to email me, okay?
Please, I'm also interested.
You just type my name and if you want to learn more about my work, and you can watch my YouTube channel. I sent you the link already and subscribe.
Yeah.
Okay. There's a lot of content there, and then visit my website. And of course, you can always contact me in LinkedIn. You just search my name, and you find me in LinkedIn. Okay. All right. Stay in touch.
Yes, we will.
Okay.
Thank you
So
so much for that very good interactive speech of yours. I hope that everyone is alive now and awake.
yes,
And yeah, I hope that more audience are also responding. It would be cool to exchange ideas and just to clarify things and ask for advices, right? Thank you so
yes.
much,
Thank
Dr.
you.
Lun Liu.
Thank you very much. Thank you for your attention.
All right,
Bye.
and I will be calling our next eminent speaker. He is a professor of data science, North University College, Kristiansand, Norway. Reviewer, National Science Foundation Graduate Research Fellowship Program, NSF GRFP, Lebanon, to deliver the keynote address. He received also 2007 PhD degree in applied mathematics from the University Blaise Pascal in Clermont-Ferrand in France. He currently is a professor of data science with Beirut Arab University in Lebanon. His research focuses are data science, AI application, system prognostics, stochastic systems, and probability and reliability analysis. In addition, he serves as an editor-in-chief of the International Journal of Quality Control and Standards in Science and Engineering. He is an IEEE senior member and IET fellow. Let us welcome Dr. Saifuddin Kadri. Go ahead, sir, please.
Hi, good morning.
Good morning. Good morning. Yes, you can go ahead and please share your screen.
Okay. So can you see my screen?
Yes, we can see it now. Please proceed.
Okay, so thank you so much. I just turned off my camera to just save a little bit of the connection.
And with yes, sure.
So thank you thank you, Jojo, for introducing me, and good morning for everyone. So this is the title of my presentation. So it's automated segmentation of COVID-19 lesion from lung CT images using unit architecture. So the problem that we are trying to solve here is to help the medical doctors and the medical sectors in general to assess the CT images, the CT medical images taken from lung, and to try to find the area or the region of the pictures that related to COVID-19. So, so the problem here is to segment the images and also to have kind of automated system. Okay, so this will be kind of helpful for the medical doctors or for the radiologist. And we are using here a well-known architecture in the domain of, artificial intelligence, or in particular deep learning, called UNet architecture. So this is the plan. We will talk about the research goal, then some introduction, followed by literature review about the problem, then our methodology, our proposed methodology. Then we will discuss the result, and we will end up by a conclusion. So this is actually the research goal. So as you know, the pneumonia caused by the novel coronavirus disease COVID-19 is emerged as a global threat and considerably affected a large population globally, irrespective of their age, race, and gender. So due to its rapidity and the infection rate, the World Health Organization, WHO, declared this disease as a pandemic. The proposed research work aims to develop an automated COVID-19 lesion segmentation system using what we call the convolutional neural network. Because at the end of the day, we are working with images, medical images. So that's why we decide to use the convolution neural network. So we are using the convolutional neural network architecture that's called UNet. The traditional UNet scheme is employed to examine the COVID-19 infection present in the lung CT images. This scheme is implemented in our work on a benchmark COVID-19 images, which is include 300 images, and the segmentation performance of UNet is confirmed by computing the essential performance.
Hello? 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 I think we lost him. Oh, there you go. Sir, I can see your screen, but I cannot hear you. We're having technical issues there, so let's give a few minutes for Dr. Kadri to come back.
Can you hear me?
Yes, I can hear you now and I can see your screen now. You can go ahead and proceed, Doctor. Doctor, you may proceed.
Okay, so as you see here, we rely our study on the biomedical images because as I said, because they can give us more information about the problem. So as you see in this slide, in this image, you can see the signal one. Maybe I can just use this one, the laser. So as you see here, this is the signal image, like when we check when we diagnose the heart signal or the heartbeat, and this is the CT image, and this is the MRI. So basically, we are using in our study the CT images. So the lung is one of the vital internal organ. The abnormality in lung arises in various situations, and pneumonia, as we know, is one of the major causes of the lung abnormality, and may cause very severe health problem among the children. And of course, we are talking here about the problem of COVID, the main issue of COVID-19 disease. So the health problem among the children which is above the 65 years old. From the recent literature, it can be noted that the infection due to COVID-19 causes a severe pneumonia in elderly people, and the unrecognized and untreated COVID-19 will lead to death. So in our proposed method, we collect. We use the data set of 300 images were collected from the benchmark data sets in these two references. So available for the research purpose and the essential performance, the advantage of our proposed technique. The proposed technique is implemented using the MATLAB software, and the segmentation binary image is then considered to confirm the superiority of the proposed technique based on the computed values of the different matrix like Jacquard, Dice, and segmentation accuracy. The experimental result with the proposed research confirms that proposed technique had to achieve a better result on the considered lung CT images and extract the COVID-19 infection with better segmentation accuracy. So what are the main contribution of our proposed work? So basically, I can summarize that we have three main contributions. The first one is the implementation of UNet framework to segment the COVID-19, so the implementation to COVID-19 region. The second contribution is we consider the clinically grade lung CT images for the experimental investigation. And the last contribution is the overall improved of the current, let's say, system in the literature, which is we got greater than 96% on the overall accuracy of our proposed scheme. So here we can see some literature review about related problems. So you can see that some researchers employed different framework for segmentation, and not only segmentation, but also for classification. Because in our work here, we just do the segmentation, and on our future work, we will use implement the classification for the images. So you can see different framework and different techniques. For example, in this one, you can see that in DEOL in reference 9, you can see that their system achieve an overall accuracy greater than 87%. Okay, so there's some different articles in the literature work on the same problem. So this is basically our methodology or our flow chart of the proposed methodology. So basically, the images that we use from the two data sets are 3D lung CT images. So basically, we have CT images taken for the lung in 3D dimension. So what we did in the first step, we convert the 3D to 2D dimension, because it's kind of very hard to work with 3D images in terms of computational. So we convert the 3D images to 2D images. Then after that, we resize the images to fit the requirement of the UNet framework. Then we implement the UNet segmentation in MATLAB. Then we got here the segmented image. Then we compare to the ground truth image, and after that we found the performance measure, computation, and validation. So this is the framework of UNet, as you see. So basically, it's a convolutional based on convolutional neural network. So this is the input image. The input image must have this size, 572 times 572 pixels. Then it will go over different different layers, and the resultant image, as you see it on the right, has the size 388 times 388. So basically, we implement this framework in MATLAB, and also we train this one on the two data sets that we collect. Okay, so now in order to see if the proposed method has an advantage, so as I said, we need to compute some performance measures. So the merit of any computer-based image examination system is confirmed by computing the essential image performance measure. So in our work, after extracting the COVID-19 lesion from the chosen test image, so here extracting means segmenting, right? So a comparison is then executed with the grounded truth image. And some performance measures are computed. And this actually, if someone wants to just understand how the different measures work, so this is the Jacquard index. As you see, this is the formula. So basically, it's equal on the quantity of the intersection between the grounded truth image and the segmented image divided by their union. And this is the dice, this is the accuracy, precision, sensitivity, and specificity. So this is actually the different performance measures. Of course, TP is the true positive and TN is the true negative. Then you have the false positive and they have the false negative. So in the result and discussion, as you see here, initially the considered UNet architecture is implemented on the two data sets, which form together 300 images, and the segmented COVID-19 lesion is then considered for the further assessment. So here in this figure, you can see a sample of the result that we get after implementing UNet in MATLAB. So basically, this is the test image, the input. This is the grounded truth, so that we need to compare. And this is the silency map, which is generated during the process of UNet architecture. And this is the result image, or this is the extracted lesion from the test image. You can see here in this slide the kind of sample of 5 images. You can see that this is the test image. This is the CT images of 5 different lung. And this is the grounded truth, and this is the extracted lesion, right? So basically, to check the performance, we compare pixel by pixel the grounded truth with the extracted lesion. So this is the two tables. So as you see here, different images. It's just 5 images as a sample. You can see the true positive, false positive, true negative, false negative. Then after we find this, we find the Jacquard dice and the different matches. So this is the result, graphical result that we get after we try our proposed scheme on 2 different sets or 2 different databases. So you can see the Jacquard, you can see the dice, and you can see the overall accuracy that we get on both data sets. So it's kind of close to 96% on average, which is a very, very good result in terms of overall accuracy. Now for the conclusion, so the proposed research work implemented a convolutional neural network. So why we decide to use convolutional neural network? Because we are working with medical, very, very sensitive medical images. So we use the CNN supported segmentation to extract and evaluate the COVID-19 infection in lung CT images. So the traditional UNet scheme is employed to mine the COVID-19 lesion from the chosen test images. The proposed scheme helped to process the images with 572 times 572 times 1 pixels, and after the processing, the implemented UNet helps to offer a binary segmented images with a dimension of 388 times 388 times 1 pixels. The procedure implemented on 300 different test images offers a better overall performance measures compared to the literature, such as the Shakard, when we get it approximately greater than 86%, the DICE greater than 92%, and the accuracy greater than 95%, which they are superior with the proposed automated segmentation technique. So this is what we did in this research. And for the future work, we will use the convolution neural network classification we included along with the UNet in order to classify the lung CT images into normal or COVID-19 class. Or maybe also we can go further and don't just classify it as normal or COVID-19, but also we can just find the severity if it's COVID-19. Further, the performance of UNet can be improved by using different architecture like VGG16 and the VGG net. So this is what we get, and this is some of the references. And if you have any question, I will be happy to discuss them with you.
Any questions from the audience?
Hello, am I audible?
Hi.
Yes. Yes, you are. Please go
Sir,
ahead.
I want to ask how you find out the ground truth or where you collected the ground truth images. Actually, I am working on ILD images and major problem is to find out the ground truth of the images. That's why I'm asking how you have collected the ground truth images or how you find out the GT
Yes.
images.
Yes, thank you. This is very important question, and this is basically the major kind of issue of many medical data sets. So basically, to get the GT images, you have to sit with a radiologist, right? You have to sit with a radiologist, and the radiologist will actually manually find the grounded truth images. But what we did here, we also discussed it with the radiologist, but the importance of the two data sets that we used, the grounded truth images are coming with them. So you can see, I can share with you if you want the link of the data set. So you can find inside these data sets, in addition to the images taken from the lung, you can find also the CT images with them in the same inside the data set.
Okay, sir. Okay, thank you. Thank you so much.
Thank you.
Any other questions? All right, and I would like to thank you, Dr. Sifidin Kadri, for that presentation. Thank you so much.
Thank you, Gigi. Thank you.
And yep, I think we have all our eminent keynote speakers. I thank both of them to a very inspiring and overwhelming presentations. Now we'll go ahead and go on to our 30 minutes break. Guys, please come back. You can just turn off your camera and go on mute, and let's go back. Oh, sorry. Let's go back to proceed with our technical sessions after 30 minutes. All right, see you guys after 30 minutes. Do we still have Dr. Kadri? Dr. Kadri?
अरे ती तर नाही ना. Hello, friends. Hello.
Hello, sir.
Hello.
Yes, sir.
Venkateshwari madam is there. Hello.
Yes, sir.
Shall we start our session? Is it there, Venkateshwari madam? Hello. Hello.
Oh,
Madam.
yes.
Sir, Dr. N.M. Pawar.
Yes, sir. Who is it again?
Shall we start this session?
Yes, we are starting now. Yeah. Welcome back, everyone.
Hello.
Welcome back. Welcome back. And again, I would like to remind all the presenters that you are given a total of 10 minutes each presentation, 8 minutes for your presentation or for your PowerPoint presentation, and allotted 2 minutes for the question and answer, especially from our chair. And also, please make sure that you have a stable internet connection because our conference will eat a lot of bandwidth. All right, so please, for technical session 2, you can go ahead and go to your respective breakout rooms. We have technical session. Oh.
Yeah, madam. Now
Yes?
we shall start from one by one. Yeah.
Hold on. I have a technical session 1. I'm supposed to be. All right. So for those who are on technical session 1, stay in this main room. All right. I would like to welcome our session chair, Professor and HOD of NMIMS, Sherpur.
Ma'am, hello.
Yes.
Ma'am, actually, Chaudhary sir yet not joined. Dr.
Not
Chaudhary
yet
sir.
in?
Chaudhary sir yet not joined, ma'am.
Oh, not joining.
Yes, ma'am. Just wait for 2 minutes. He is joining.
Okay. Oh, by the way, can you move to assignment session?
Hello.
Yep.
Ma'am,
Hi.
how to join technical 5 session?
Okay, just right below your Zoom, you can see there at the bottom chat, participant share screen, and
Yes,
there's more. Click on more and click on breakout rooms or join breakout rooms, and you will see their technical session 5.
Okay,
then click on
Thank
join.
you.
All
Thank
right,
you, ma'am.
well, you're welcome.
Oh, Mary is coming.
Hello.
Hi, yes.
Ma'am, on more, it is only coming chat and record on this computer. These 2 options are only coming. How to join to technical session 3?
We have actually technical session 1, 2, 3, 4, 5. Please disregard technical session 1 because we will stay in this main session. Technical session 5 is there. Can you see their breakout rooms?
Actually, in more options, I can see only 2 options, chat and record on this computer. Only these 2 options are there, visible for me.
Can you please leave and go back?
Okay, I will
Leave the meeting and join again, please.
Actually, here it is giving host is inviting to join the breakout room technical session 5. Like this, we are not getting. Here, one tab is coming actually.
It's not showing?
Okay, I will join the breakout room. Okay, breakout room. Through that, we have
Yes.
to join.
Yes, please click on breakout room, and on if you are on technical section 5, please click on join just right beside technical session 5.
It is for technical session 5. Likewise, we will get for technical session 3 also, no?
Yes, that is correct.
Okay, okay. Thank you.
Hello, hi. I am from technical session 5 as well. Could you explain the procedure again?
Okay, just when you see there your Zoom meeting, our Zoom meeting, just right below, you can see their mute video, participants, chat, share screen, record reactions, no record reactions. Then you can see there more with the 3 dots. Click on that one and you will see their breakout rooms. Then click on breakout rooms and you will see there all the technical session. And you can see there a join blue button on just right beside the technical session.
More options is not available.
There's no, I don't see any option to join. I can see the technical rooms and can't see any option to join that.
It's just right beside it. It's a little button. Join. Let me. Hold on. Let me send a photo of that. It's supposed to be looking like this.
Ma'am, more options is not showing on our screens.
Yes, ma'am, it is not showing.
Ms. Deepika, you have to update your Zoom version. That's why it's not visible for you.
Oh, yes. Your Zoom application should be updated, or most probably the updates on your laptop is not installed yet. It's supposed to be automatic. Yeah.
Hello, ma'am.
Yep.
Dr. R.S. Chaudhary sir has joined session.
Yay. All right. One moment. Right. Since we have Dr. Chidari. Oh, he's in technical session. Let me.
Chaudhary sir is a chairperson of our section 1, track 1.
Yes, hold on. Dr. Chidari.
Good afternoon.
Hi, good afternoon. All right, we have now our session chair and we will now commence our technical session 1. All right, everyone, let us welcome our one of our session chair, Professor and HOD of NMIMS, Shirpur. Let us welcome Dr. R.S. Chidari.
Good afternoon, everybody.
Hi, good afternoon. Let's go ahead and commence. Let me call on our first paper, vibration analysis of cantilever beam using magnetorheological fluid. Hello? All right, let me go ahead and call on the next one. Electric vehicle chassis design and structural analysis by using CAD and CAE techniques.
Shall I share screen, ma'am?
Not yet. Can you share your screen, please?
Okay, thank you. Hello, good afternoon,
Right.
all of you.
Go
Shall I
ahead,
start?
proceed.
Okay, thank you. Good afternoon, all of you. This is the Ishwar Bansode. I'm a ME Design second year student studying Dhole Patil College of Engineering, Pune. And my paper title name is Electrical Vehicle Chassis Design and Structural Analysis by using CAD and CA technique. My presentation author are Mr. Maheshwar sir and Mr. Hanumant Narute sir. So before going in deep with presentation, I would like to share some point about this project. Why I have chosen this project as my academic project as well as presentation for this international conference. We know the petrol prices day by day increasing very high, and it has adverse effect on our environment. The burning of these fossil fuels generate very toxic and poisonous gases like SO2 and CO2, and these are the gases responsible to greenhouse effect. Few days before there were a calamity happened in India, that is Toyota thunderbombs. This such calamity because of such regions. To avoid such calamity, we have to go for we have to change our automobile sector to some conventional use of fuels like electrical vehicle. The production of electricity is available easy as compared to the fossil fuels. So I have chosen this topic. This is the okay. This is my biography. I'm a CA analyst working as a CA analyst in John Deere Pune, having 5 years of experience working on linear, nonlinear analysis, dynamic analysis, hypermesh OptiStruct. This is the abstract of my paper presentation. Electrical drive vehicles are becoming an attractive alternative combustion engines car with the global casual fossil fuels price rises. And to present this paper, I have used ANSYS Workbench as a solver to solve. This is the content of this paper: introduction, problem statement, scope and objective, literature survey, methodology, description, and all. Before going in deep with the chassis analysis, I would like to give some summary about why I have chosen and which type of chassis I have chosen for this presentation. There are different types of chassis available in the market. I have chosen box type of chassis, and the reason behind it that is that box type chassis is good for both torsional and bending loading, so that I have chosen this chassis. Other than this, there are different chassis like integrated frame chassis, semi-integrated frame chassis, conventional frame chassis, tabular chassis. Tabular chassis are good for resistance in torsion, whereas C chassis are good for resistance in bending because due to its shape. You can see that what is the main aim of this project or paper is to enhance the overall performance of the electrical vehicle optimization. It includes weight reduction, battery performance per charge, overall cost by changing the chassis design. What we are doing here, whatever the dimension we are obtaining here, those dimension we are obtaining from reverse engineering application and making some changes in that design, and we are coming with new chassis with the reduction of weight, with the reduction of chassis weight. Actually, in any vehicle, almost more than 60% of weight of vehicle, only chassis include 40 to 50% weight of entire vehicle. So that our main concern is to reduce the chassis weight so that we can improve our performance. Scope and objective to run chassis for electric three-wheelers by utilizing CAD and CA techniques. This is the literature survey I have done before starting this project. We can see the different types of chassis: conventional frame, integrated frame, and semi-integrated frame. This is a general ladder type of chassis. This is the methodology. What methodology I have followed for this simulation is that dimension of the chassis are obtained by reverse engineering application, and CAD modeling has been performed in SolidWorks. Static structural analysis of the existing chassis performed by using ANSYS solver. And static and bump analysis is carried out to check whether the modified design is suitable for a given application or whether it is used to reduce weight and improve the battery performance. This is our product. For this product, we are designing chassis. This is the specification of this vehicle: overall length, overall width, overall height, battery specification, mileage per charge, cost per charge. You can see here how much cheap electrical vehicle as compared to the fossil fuels vehicle. The current price of petrol is more than 100 rupees per liter, but here it is 40 rupees per 5 to 7 units, and charge time, and it will go 250. It will the same cost. 100 rupees for petrol and 40 rupees for electric, means almost 60 rupees saving with the use of this. Well, this is the loads on chassis. What are the loads we are going to apply on chassis? All are the realistic loads, means what are the load we have obtained? We are obtained by considering the real life condition, situation or condition. Payload, battery. This is the battery load in kg, driver weight, and miscellaneous, means the other weight in that vehicle. Material selection, we have chosen material selection as per American industry standard. 1045 medium carbon steel. Why I have chosen this carbon steel? Because it is a good weldability of this material. And this is all the engineering material data: density, Young's modulus, Poisson's ratio, yield stress, ultimate tensile strength. This is the nomenclature of our design, what we have done in this, and this is the image in ground floor of this vehicle. This is the image of modified chassis, side view, front view, and side view, how this look. Pre-processing, post-processing, and solution. What are the dimension here? We are obtained by SolidWorks by using reverse engineering application, and the same geometry imported into ANSYS workbench for the meshing purpose. Why we do meshing and all in CAE? Because to reduce the physical prototype, that is why we have chosen CAE. And geometric and meshing is done in ANSYS workbench. Meshing is done as per meshing standard, means element type. As per element type, we have chosen as per geometry. If it is a very solid material, means if the component thickness is more than 12 mm, we have gone for solid meshing. If it is less than that, we have gone with 2D planar meshing. Or for beam, we have gone for beam. Or if it is spring, we have given spring element. And different type of element has different type of property. Means if you consider shell, in ANSYS it has shell 163, solid 185, beam B31, C beam. This is the advantage of using CAE. And so in the next stage, we have run this process in post-processing by using ANSYS workbench, and the same result we have plotted in Hyperview. This is the FEM model of this assembly. The number of nodes, number of element, what we have generated with the use of ANSYS workbench, and where we have applied. This is the main concern, where we are going to apply loads and boundary condition. First of all, I would like to tell that what is the loads and boundary condition. Boundary condition is nothing but a constraint, means we are fixing something so that the application of load restricts. Here we are, our main concern is to constrain the degree of freedom. Degree of freedom is nothing but number of independent coordinate to specify the position of any entity component in the space. It's called a degree of freedom. Here we are applying vertical download load. So that vertical download is negative Z direction load. So that why we have chosen vertical download load? This is a gravity load. Okay. And we have given constraint to all the 4 wheel where this vehicle sits. Here you can see that. Here we have applied the constraint in all degree of freedom. Current design FE result. You can see that here the current FE result, maximum deflection observed 3.02 mm on the front mirror frame and 2 mm deflection observed at the center location of the top frame. Here you can see that here maximum deflection we have observed after application of gravity load. Von Mises stresses. Why we have chosen von Mises stresses? Because this is the steel material, and steel material is ductile material, and von Mises CS3 is 3 hold good for ductile material. And as well as this is the average average shear stress theory, because it consider both principal stresses as well as shear stresses. In another name for this theory is the fortified angle theory. Also, we can call this one, which is shear stress theory. And the stress observed with the views of this theory is 308 at the location of hole. You can see that in the image. This is all in the current design, means we can call this is a baseline design, and the iteration one design is this, that is the modification we have done. We can very clearly see that what is the modification we have done. I will show you what are the modification we have done. Here H frame has been simplified, and some members have been removed on which no load was acting. Means those members are ideal, means they are not taking in the part of loading. Unnecessarily they are adding weight in our assembly. So what we have done here, we have removed this type of structure. Here we can see that in suspension frame, it has been modified to distribute the load to the entire frame. Some change channels have been reoriented from higher load bearing. In previous, here we can see that side rail in front rail attachment. This is the unnecessary part we have removed, side rail attachment. For aft tube shortened because no load is taking. This we made it is shortened because it is not taking any load, so that we reduce its size. This is the displacement we got. We got a reduced deflection after changing. Before that it was 3.02 mm, and now it is 2.6 mm. Means after changing the design, there is no effect on our structure. We got less deflection value, and our design is safe in terms of deflection. In terms of stress also, before that we are getting more than 308 MPa. Now we are getting 740, around 775 MPa on the rear side of the frame. Means the design is safe after changing the chassis design, and even the weight reduction also happened. We can see that the weight reduction also. For dynamic, means this is the static. Up to now we have done the static analysis. For a dynamic analysis, this is the realistic result we get in dynamic analysis. So we have done bump analysis of modified design FEA chassis. We can see that this is the time and this is the acceleration for a dynamic loading, and this is the 3-jump profile applied on loader vehicle. Displacement plot for modified vehicle. This is the time and dynamic loading, means load is varied with respect to time, and variation of displacement with time. This is the comparison between current and modified design. We can see that this is the comparison we observed. Here 1.7 mm and here 2 mm deflection. After changing, reducing weight or removing unnecessary part so that it improves our design, we get this type of result. This is the conclusion of this paper. Electrical vehicle chassis has been developed based on the existing model, and all conclusion, detailed structure analysis has been carried out, considered self-weight of the chassis. At the end, we can see that with the reduce of chassis design, we improve the battery performance. We reduce battery performance. There are a number of papers. We can see that here after reducing the chassis design, we got improvement in battery performance, and even the capacity of vehicle to travel more distance per charge also improved after removing the unnecessary part from chassis. This is the all about this presentation. Thank you.
Thank you so much for that presentation. Do we have any question from our chair, Dr. Tudari?
Yeah, good afternoon, Swapnil. Good afternoon, ma'am Jojo, and good afternoon, Mr. Ishwar.
Good afternoon, sir.
Yeah, it is very good to see your presentation that I'm watching. Yeah, you're working on electrical vehicle chassis systems, suspension systems. My basic question to you is that, am I audible first? Let me know.
Yes, sir, you're audible, sir.
Yes, you are.
Thank you. So my first question to you is that, what are the major design goals to be considered while designing any suspension system of the vehicle?
Pardon, sir. Could you please repeat it?
What are the major goals or what are the major aspects to be considered while designing the suspension system of vehicle?
The main concern while designing any suspension vehicle or chassis is about the weight of that chassis. thickness of the chassis, so that whether it is able to withstand the given application of load. Means suppose if you take lesser thickness and our load application is more, that the design is will not be safe for our application. This parameter, after that we need to choose what material we are going to use. This is the second most important parameter, because material selection is the most important property, because every material have different strength. According to that, we have to choose most grade material. Means which grade material will give us more specific value, so that we can reduce that all we will meet our requirement.
Okay, I got what you want to say. I'm eager to know that when you reduce the weight of your suspension system you have designed, is there any effect that you have observed in vibrations? Because vibration is directly related to mass.
Correct. Because it is directly related, means natural frequency is equal to under omega or W by M. It is directly.
Okay, sorry to interrupt you, Ishwar. When the mass or the size of the chassis has been reduced, then of course the mass would have been reduced. So due to reduction of the mass, is there an effect on vibration that you have observed?
Yeah,
because
it's it is inversely proportional to mass. Obviously, if you reduce the mass, means natural frequency will go increase. So that, but it would not that much adverse effect on our chassis. I mean, we can run safely our vehicle.
Okay, I hope you consider that.
Yeah, we are considering that pass, that accept also. We are checking resonance of that vehicle. Means whether by resonance we are checking with the help of natural frequency whether our vehicle natural.
I think that will be the next part of your study.
Correct, sir.
Okay, I'm good. So, which type of mesh you have considered?
I have chosen mesh type as per geometry. I have mentioned, means if it is a thickness of that part is more than 12 mm, I have chosen solid mesh for that. And if it is less than 12 mm, I have chosen 2D planar mesh. The element type is for shell element, it's shell 163, and for solid element, solid 185. This is the standard in ANSYS workbench.
Yeah.
And for beam element, I have chosen C beam, and for spring element, spring element.
Can I ask you a basic question about meshing? Which type of which type of mesh is good for the frame design, or which type of meshing gives the strongest design?
Actually, solid mesh is the strongest design for any design, but due to the complexity of geometry, most of the time we go with 2D mesh or 3D mesh. Why solid mesh is strong? Because it has less degree of freedom.
Okay, I'm eager to know in details which type, maybe square, triangle, circular, what type of mesh?
It is a mixed type of mesh. Means mixed type of mesh means chord and triads.
Okay, triangle as per my knowledge, triangle design gives the strongest, but you are correct at your end too, because depending on the geometry as well as the thickness of
correct. Why we have chosen mixed type of mesh means there are some feature they are ending with triangular shapes. In such a reason, this tri element will fit strong. We can choose a tri element throughout, but what happen if you taken all the element is tri, and tri element is very strong in it will add extra strength to the structure, so that we avoid that element. And chord element for result perspective point of view, chord element has have 4 integration point, and chord tri element has a 3 integration point, so that it will give more realistic result.
Okay. How important is the bump analysis along with the static analysis, do you think?
Sorry, sir.
How important is the bump analysis that you have done with this?
Okay. A bump analysis means we know in any road, bump analysis will tell us the realistic condition, because we are traveling on road, we got some potholes, or sometimes you got some road breakers. We need to check what happened, our vehicle is going in such conditions, and such condition automatically our weight get reduced with respect to time, because if you go to the pathway, we need to reduce our speed. Or if you go into the breaker, we need to reduce our speed. So what is the load acting at this situation? We need to consider, so that in this case load is changing with respect to time, so it will give result to us in a different situation, what is the effect is going to happen on our vehicle.
Yeah, probably you have considered it is same or similar with the fatigue analysis, you said?
It is not fatigue. In fatigue, we will change with a cyclic loading. Means there is a load is a cyclic and a cyclic repetitive type of loading. And there we consider endurance limit of the, there is one endurance limit in fatigue. Fatigue is mostly for life prediction.
Yeah.
Here we are checking material damage, means after different condition, what material damage is happening or not.
Okay. Somewhere you mentioned, this is the last question. I'm sorry, I may be extending my time. So somewhere the reduction in deflection you have found from 2 to 1.7 mm.
Yes, yes, yes.
So how much effect it is going to, because 0.3 mm, difference in the suspension, is it sufficient to give the good results?
Not that much, but thing is that this is in 1 point result we are checking, means at one location where we are getting maximum. If you consider the entire vehicle, obviously it will affect to the performance of vehicle.
Okay, means it is the spot deflection that you have considered.
Yeah, means which spot we are getting more deflection.
Okay.
Comparing two spot with current design and proposed one.
Okay, that's good. That's good. It's all from my side. It was very good to listen Ishwar through his presentation, and I hope he will do more analysis in future because he is working for his masters too. So all the best, Ishwar, and it is nice to see you. Over to you.
Thank you. Thank you, sir.
Thank you so much for that interactive Q&A, and thank you so much for your presentation, sir. Now I'll be welcoming the next paper about optimization of socket and power lift gate assembly by Aniket Suresh Jagtap.
Yes. Hello, everyone.
Hi, yes, I can hear you, and you can go ahead and please share your screen.
Yeah, I will share this screen. Is it visible to everyone?
Yes, it's now visible. You can actually just put on mute your phone or YouTube coverage so that it will not create the feedback.
Okay. Just okay.
And you can go ahead and proceed.
So shall I start the presentation?
Yep.
Good afternoon, everyone. Myself, Aniket Jagtap, and my project title is Optimization of Socket in Power Lift Gate. The Power Lift Gate assembly means, under the guidance of Professor Yogesh Indulkar and Professor Anup Wani. In the biography, Aniket Jagtap comes from Pune University and graduated from Pune University as a mechanical engineer with a distinction. After graduation, I completed I worked with different industries for 3 years as a simulation engineer, and now pursuing the post-graduation from Dole Patil College of Engineering, Pune, in design engineering. And after post-graduation, I'm planning to pursue career in automotive industry as a subject matter expert. This is the future goal. In the abstract, the purpose of this work is to model and simulate the static and dynamic behavior of electric powered lift gate, we call it a PLG. And after the adaptation to the ambient condition, the model is verified and validated with the physical test. And the model is should simulate with both static and dynamic behavior of power lift gate systems. The practical advantage with the simulation is like we can avoid number of tests without entering the hardware, manufacturing any hardware. So in this project, we use the ANSYS workbench to build the simulation model, and verification will be done by comparison between the physical test and the simulation results. So in introduction, I will explain the where it is power lift gate located in the vehicle and how it works. So this is a vehicle where the tailgate is operated with electronic devices like motor and with gear. With the motor, while using the manual control, we can open and close this tailgate. So at this location, the ball joint is present. And so this is the unit vector diagram for the operation of opening and closing. This is the center of mass of door, and it moves towards this point. So according to that, this is the movement shows the, and this is the topology of multi-body system. So where from position 5 to 0, it opens and closes. So this is these are the various joints used for these operations. This is the operation, like how it opens and closes, like how when it will take end position and when it will close. So our main purpose is to understand the various forces applied on those ball socket joint. So this is the diagram of ball socket joint where this pinion is fixed in the vehicle body, and this direction shows the our this spindle direction shows in this direction, and this ball socket is currently with the steel material, and we are optimizing with the polymer material. So this is the introduction of our geometry. And the problem statement is like this new LPG spindle socket will have to satisfy the standard as per the customer specification, and also required to consider design variables like change in length, low cost, and to check the new optimized design with the shape, with the material, and the safety point of view also with the tensile and tensile testing and buckling testing. So why we are considering the polymer material against the steel material? Like the steel material have high machining cost, and while operating the steel component, the noise level also high, and the overall weight of this steel ball is also high. So we are trying to avoid these things with the polymer material. And the scope and objective of this optimization is like to check the plastic strain and principal stress under the tension loading, and it should be within our standard limits set by industry. And so we are checking with the plastic strain and principal stress under the tension. Why plastic strain and stress? Because it is a polymer material, and it will fail due to the plastic strain and principal stress as a brittle material consideration. And we validate this with the physical testing. And the scope is like we are benchmarking the simulation model, and after that we are trying various materials without doing any actual physical testing, so that can reduce our time and cost also. The literature review, we did various paper analysis, and we observed like the first paper is modeling and analysis of automobile chassis using the composite materials. In this, we understand the different material and parameter to be checked while optimizing the material, and observe the modeling approach and the analysis method to be carried out. Second one is reducing and optimizing tailgate closing effort in the automotive car. Yeah, in this we understand the various boundary conditions and environments for the tailgate operations, and understand various load paths where from which direction the force will apply, or from which direction it will have to constrain the system. So these things are studied under this paper. Next paper is structural analysis of automotive chassis frame and design modification for weight reduction. In this paper, we understand the effect of reduction of weight on the system, how it will affect the various parameters, and how the shape optimization also works, or how it behaves. We can see. And the fourth one is the design and analysis of automotive mobile frame to reduce the force distribution on accidents. The shape optimizations means we are distributing the force coming on our surfaces. So this study is observed under this paper. So next one is the our finite element analysis model. In this, first we create a geometry from the Creo. Then we took into the ANSYS, and we meshed the model with the solid elements because we consider all element as a solid. We are not taking any, means there are no sheet metal parts, so we consider the solid materials. Then we apply the boundary conditions. Then we solve it like it is a non-linear analysis, so it will take a number of iterations to converge the model, and after that we interpret the results. So first we do two analyses, one with the structural steel material and another is the gravity material, which is a polymer material. So both for both materials we use a nonlinear curve. What is nonlinear curve means after the yield point we consider the stress strain data from the testing and put it into the analysis. So it will follow the curve with respect to the stress. So after that, contacts, we given the contacts as a non-linear contacts because it will be while correlating with the test, it will reduce the error percentage. So it will be like a real model in the software. So we use a non-linear contacts for this model creation. Then meshing. In meshing, like I said earlier, we use solid mesh as there are no sheet metal parts in our assembly. Yeah, and we use a higher order mesh to capture the results. Hello. Hello.
Yes, we can hear you. Please proceed.
Okay. Yeah. After the meshing, we apply the boundary conditions like this blue part shows that we fix the model in the all direction. Fixing means it will not move in any direction. And we apply the remote force from 30 mm distance to this ball socket joint. So while applying the rigid force, there are two behaviors for this force, like one is rigid and one is deformation. What is rigid? I mean, it is not allowed to deform the surface where we apply the force, and it will transfer to the next load path component. So if you apply 20 kilonewton force, then it will transfer next part to the 20 kilonewton, means rigid transmission. If you are considering deformable, then it will absorb some force, and then after that the remaining force it will transfer. Like you apply 20 kilonewton, then it will absorb some 1 or 2 kilonewton, and after that it will transfer 18-19 kilonewton force to the next part. So after boundary condition and after solution, these are the simulation results where we check the equivalent non-Mises stresses for the steel material and by avoiding the contact surfaces, and it comes around 460 MPa, and ultimately stays also 460 MPa. And so we check the force reactions for where we apply the remote force, and those are around 5,000 kilonewton. Similarly, we check the results for the gravity polymer material, and in this we check the plastic strength and for this material, and it is around 1%. And the force at the strain limit is around 5,000 Newton. Similarly, we check the maximum principal stress on the model by avoiding the contact stresses, and also the similarly force reactions. After that, we did the experiment with the UTM, universal testing machines, which has a specification like its range around 400 kilonewton, and its least count is 0.04 Newton. And in this, we placed our optimized joint. Optimize a ball socket joint in the fixture base, and we took one arm which will help to apply the force in this upward direction. It is movable, so that we record the strain and the force observed during this testing. And this, in summary, we compared FE results with the experiment and checked how much percentage error are observed. So our percentage error around for steel is around 11%, and for polymer material it is around 3%. So we conclude like yes, these are under acceptable limits, like they are not more than 15% percentage of error. So we can go ahead with the with the parenting is our model for the further material test or any shape optimization. So we can consider this.
Thank you so much for that presentation. Are there any questions from our chair?
Yeah, good afternoon, Aniket. It's nice to listen to you for a long time. I have a question, basic question to you. What is the meaning of optimization?
Optimization means we have to improve the design with the same system to just like reducing the cost some of the areas.
Yeah, so multiple parameters are to be considered for optimizing, either from one material or multiple materials are to be considered for the same parameters.
We check how much means we have availability of materials, where how much we can consider the cost or against the manufacturing.
So how many parameters you have considered here?
Here we consider only the in this we consider only the cost consider. I think we consider not more than that.
So when you consider cost, I think more than two materials, you have considered two materials only. It is a replacement of steel by some polymer. If I'm not wrong. Okay, so somewhere I have a suggestion for you. Don't take it in a adverse way. Instead of optimization, some another term can be used, because in optimization, multiple parameters or multiple materials are to be there, from which you have to consider one. So in two materials, I seems difficult to consider it as optimization. Secondly, going ahead, the figure that you have shown about the lift gate, is this figure is your own figure or you referred it from somewhere else? In the second slide.
In second slide. Right?
Yeah.
This one. Right?
Yeah.
This one I this one I took from internet to just extend the.
Yeah, it is from someone's paper, as I know. So you can put a reference there, or you can put as a source there below the presentation, at the bottom of the slide.
Okay. Yeah, I will do that.
Okay, in next time. Okay, what type of material is SS439?
Yes. It is ductile material. Yes.
No, what type of material? Which type of material? Whether it is, okay, I know it is steel, but which type of steel is this?
This is grade 8.8.
No, can you classify in which type? Whether it is austenitic stainless steel, whether it is stainless steel or alloy steel, ferritic steel.
It is stainless steel. SS439. Right? It is.
It is 439 stainless steel. Okay. So chromium is prominent in the stainless steel, as per my knowledge, and it is used mainly for known for its good weldability.
Yeah.
Okay. So are the material you are using polymer, can we replace these features that this steel have?
Weldability. So actually, in this we don't have my. It is a press fit. So
I'm asking in general, whatever features this steel has, because it is a chromium titanium stable austenitic stainless steel, which is known for good properties. It is similar to SS304, you can say, austenitic stainless steel, when it comes to corrosion or etc. etc. So what I mean to say, all the properties of these materials, those are required for the lift gate, can be replaced with the help of polymer.
No, but our main agenda is like we have to check against the mechanical forces for this. So
that I am asking you.
These are the phases. These are the phases for optimization. So one phase I did for this is like where how much our mechanical force comes on the system, and after that we if it is passed in this, then we can go ahead for further details like how much it will take, as you said, the properties.
Yeah, I'm coming to that point too, because you have considered only you have replaced the material considering its strength. You are saying that the strength is sufficient to withstand the forces that those are acting on it.
Right.
Yeah, but at the same time, somewhere, my friend, we need to consider other factors. Whether, for example, though the strength is same, though the mechanical properties are same, are the other properties are adversely going to affect the working For example, lift is a moving component, lift gate is moving component. And when there is any dynamic component, other factors are to be considered. So in future, you can take care of this thing. You have to think about it. When you replace some material, not only it is to be compared at one parameter like mechanical strength. We have to consider other parameters which may be affected after replacing the materials. So please think about that. And I can say good luck to you. It is nice to
I will consider those parameters. And, nice to meet you.
Okay, thank you. Thank you. It's all.
Sorry. Yeah, thank you so much. And are there any other feedback questions? All right, then I'll be calling the next paper, Rainwater Harvesting, an effective implementation in coastal area of Mumbai by Jyoti Nimji. Again, let me call on the paper titled Rainwater Harvesting, an effective implementation in coastal area of Mumbai by Jyoti Nimji. Right, let's call on the next paper about utilization potential of bagasse ash, lime sludge, and coal fly ash blend in concrete as replacement of ordinary Portland cement by Maria Catherine Arca.
Excuse me, ma'am.
Yep.
I think
yeah, it is
this is not a list.
This is not the list.
Oh,
yes.
I'm sorry. Thank you. Thank you. My apologies. I'm sorry. Next paper, experimental and FEA of automotive composite leaf spring shackle by Prashant Patar. Thank you so much for correcting me. I apologize. All right, I can hear you. Please go ahead and share your screen.
Sure. Thank you, Jojo. Let me share my screen.
Sorry.
Please let me know if you can see my screen.
Yes, I can now see it and I can hear you. Please proceed.
Okay. Good afternoon. My name is Prashant Patar. So my project is project topic is experimental and FEA of automotive composite leaf spring shackle. Okay, and my guide is Professor Anantrama B, and guide another guide is Sidram Biradar. So let me start my presentation. Okay. So my name is Prashant Patar. So currently as a student in machine design from Dole Patel College of Engineering. So initially I have completed my diploma in tool and die making and finished my mechanical degree and started my career in 2000 initially as a tool and die maker. Then I have worked in many industrial departments like manufacturing, quality, supply chain, and product design. So currently, I feel lucky to get this post-graduation degree with exploring and understanding, learning on analysis, and I want to present my work on this project. Yeah, so this is the abstract of this project. So leaf spring shackle is used in suspension system of automotive vehicles. So it is a free hanging part which connects the frame of the vehicle and to the leaf spring suspension system. So currently it will be it will be joining the leaf springs to stretch to the when the automobile moves. Shackles are a very crucial part of the suspension system here. The arrangement tends to tensile, bending, shear, and to floats. So this may cause failure of the suspension systems until and unless the shackle, one of the crucial component which is capable to bear the load. Currently in experimental investigation in this project, the new leaf spring shackle will be done by strain gauge technique investigation of the optimized model, and comparative test results with FEA analysis in static condition are done on the optimized shackle with composite material, and those will be concluded with validation and details. So introduction. So as I said, leaf spring shackle is used in leaf spring suspension systems, and it is a free hanging part which connects the springs to frame of the vehicle. Yeah, coming to the problem statement. Yeah, as I said, the shackle is very important, crucial part of the suspension system. Um, the vehicle would be unable to expand if there is no leaf spring and shackle assembly. So if the car hits bump, the tire would have no contact with the road surface. That the shackle helps the car or the any automotive vehicle to adapt and remain steady on the uneven road surface. So while dealing with the replacement of leaf spring shackle is very important. So the objectives of this project is to study, perform the static analysis on the underloading condition, to propose an optimized model, starting with the CAD modeling creation on CATIA software, to perform static structural analysis of optimized shackle on ANSYS 19 workbench, to perform the topology optimization, where we can explore the possibilities of weight optimization also, and for the validation purpose, experimental strain gauge testing on the optimized shackle will be done on universal testing machine. Prior to that, we have done strain analysis also. So the methodology is to understand the problem of leaf spring shackle, and CAD modeling, finite element analysis, design optimization includes topology optimization also, and final specification for validation. So this is the 3D model, which is the existing 3D model. And we started with analyzing the current existing model. The material is EN45. It is a type of spring steel, and we started with meshing. And for the as we are conducting for static loading analysis, we have applied static structural loads, and we have come up with understanding the model. We want to use a composite material into this shackle, where it can be a hybrid component using two materials, that is EN45 and epoxy E class. I think you can see the area where the color is changing. So in that area, we have pointed out to add the epoxy material. So we did the analysis of the optimized leaf spring with nodes and base material weight and E-class fiber added weight. Okay. And structural boundary condition we have applied at the fixed supports and with the force of 1500 Newton. And this is the static structural analysis after optimization. So after optimization of the shackle, we have tried to understand which is the area where the strain is maximum developed here. So this is the area where the flagged showing 6.5 value of 65 micron in the optimized model. So we started with the experimental test setup with the fixed conditions To simulate them, we have added the fixture to simulate the real static loading conditions, and then applied the load in UTM, and we got the strain value of 78 microns. To recall, the analytical value we got was 65 microns earlier. And the comparison of the deformation and stress values are marginally similar. The existing model of the shackle total deformation is 0.159 mm, and new optimized model of shackle has 0.016 mm, which is very good in outcome, and one measure stress of 14.805 in existing and 16.295 megapascal in new optimized model. So the topology optimization of spring shackle is done by analytical method, and the reduction weight is observed to be 6%. The component weight is reduced from 3.79 to 3.58 kg. The application of composite E-class fiber is done by hand layup method, and the strain values are plotted accordingly. And these are my literature review and references. Yeah, that's it I have.
Thank you so much. Do you have any questions from our chair?
Yeah, actually, let me ask you a basic question. What do you mean by topology?
Topology, yeah, you are audible, sir. A topology is related to the geometry, where it shows the topology optimization. There is a tool which we can use in an ANSYS software, where it shows how the component can be optimized, where the bulky areas are to be removable, or it shows the possible optimization for the area of any component which we give feed.
Okay. So nowadays, which of the material is used, you said, in the shackles?
Currently, it is EN45.
What type of material it is?
It is a spring steel, sir, as I know.
Okay. Can you tell me what is its feature? What's its properties? Why it is used in shackle?
So as we know that it is used in suspension system, which is a very critical suspension area. So it must have the better flexibility and rigidity to bear the loads of leaf spring and the road conditions also.
Most importantly, it has a good spring index or spring properties.
Yeah.
Okay. How you selected the boundary conditions in this optimized model?
Yeah. So we want the boundary conditions are we want to simulate the actual contacts and fixed contacts, as we know that it is contacted with starting from the frame of the automotive vehicle, which we can say chassis, and then it is later connected to the eyelet of leaf spring system, suspension system. So these are the two both boundary conditions, and the load applying is also one of the boundary conditions we can say. Acting loads.
You are going to replace the existing model with some composite material.
Yes.
Yeah. So how you selected that composite material?
Yeah. So we have that references used reference research paper and other details, where this particular epoxy fiber has a good bonding addition property, and better wear and structural properties, strengthening structural properties. So that's why we have used this. This is called as glass fiber reinforced polymer. So we have a based on a paper we have chosen this. Based on a research paper we have chosen this material.
Okay, I hope you have taken this material. You have to, conducted the experimental work too.
Yes.
So from where you made it purchased or you made it here composite with you?
No, actually, this is one of the sponsored projects. So I am working.
You might have got it ready.
Yeah.
Okay, because in lastly, I will have one suggestion for you, because when you use any composite material, the orientation of fiber plays important role. So, for example, if the orientation is longitudinal and if you are applying forces in transverse direction, if you don't know what is the orientation of that, then it may give different results than the second direction of the forces. So that's why the direction of the fibers in the polymers are also having a more important effect. So we need to select against the direction of the fibers so that it gives the maximum strength to bear.
Okay.
Okay, that's it from my side. Over to you, Jojo.
Thank you so much. And thank you also for your presentation. Let us welcome the next presentation, experimental testing in FEA analysis of composite car front bumper by Pritiramesh Deshmukh.
Yes.
All right. Please go ahead and share your screen. Yes.
My screen is visible? Hello?
Yes, it's visible.
Okay. Okay. First, I will introduce myself. Myself, Preeti Deshmukh. I am from Department of Mechanical Engineering, and my college name is MES College, which is in Wadia campus. I am a ME student. This is a part of my ME project. Title of my experimentation is Experimental Testing and FA Analysis of Composite Car Front Bumper. Introduction. We all know automobile bumper. It is a structural component of an automotive vehicle, which is designed to prevent and reduce the physical damage to the front and rear end of that passenger motor vehicles. The main aim of the bumper is it absorbs the impact energy and distributes that stress in perpendicular directions of that impact. With the role of safety, fuel efficiency, and gas emission of gas regulation, all are important part. When we manufacture any car parts, first of all, fuel efficiency and role of safety, both are important parameters which are considered. Here, I have a well-designed car bumper. It must provide safety for the occupant. Also, it should have low weight. As per the research, for fuel efficiency, it is 70% depend on the weight of that vehicle. The main aim of this research is to enhance the performance of that frontal impact beam by optimizing its structural parameters using the crash and model analysis. Here in this project, it is for replacing that original material, which is a polyethylene material of that bumper. It is proposed to manufacture the frontal impact beam using the glass fiber epoxy hybrid composite material. And the new composite is developed with the design parameters. All the mechanical properties are obtained from the lab testing, and the obtained properties are used for the simulation and model analysis purpose. And final results have been verified with the existing polyethylene material bumper. problem definition. In the present study, it is analyzed from various literatures. After the careful study conducted for it, it has been found that the scope of optimizing the strength and reduce the weight by replacing the material of that frontal impact beam with glass fiber composite material is there. There are two kinds of the impacts, that is elastic impact and plastic impact. In elastic impact, what happens? Little bit of energy is neglected, which is lost between the two impacting objects. While in plastic impact, there is great deal of energy is dissipated between collision between two impacting bodies. The type of impact which is considered in the front bumper system here is elastoplastic impact, because here several crash force exist, and to analysis of the lightweight material, glass fiber composite is selected as the material of the bumper beam instead of the original polyethylene material bumper beam in order to achieve the lightweight design. Objectives of this project are, first objective is to modeling of the existing polyethylene material bumper beam of a four-wheeler using the CATIA V5 software, and the model and second is model analysis of that existing and glass fiber composite frontal beam using ANSYS software. Third is manufacturing of that glass fiber composite frontal beam using hand-lay method. Fourth one, to perform the experimental testing of existing and optimized model of frontal impact beam using the FFT and impact hammer test. And finally is experimental testing and correlating the results of both. Methodology used for this is first of all started the work of this project with some literature survey and gathered research paper which are useful in this topic. After that, model analysis of the frontal car beam of that vehicle and the selection of the car beam which is required for our project. After the selection of the frontal impact beam, 3D model and drafting will be done with the help of the CATIA software, and model analysis of that existing and the composite FIB will be done with the help of the ANSYS using FA. After that, experimental testing will be carried out, and in last, comparative analysis of results of the experimental and analysis result, and final results and conclusion will be drawn after these results. Now, design of the frontal impact beam. This frontal impact beam is designed using CATIA software. This is the drafting of that bumper beam. All the parameters are considered from existing bumper. Some are assumptions also. All parameters are considered from the existing bumper beam only, which is considered as mold here. And after that, finite element analysis of that model. First of all, that model is imported in ANSYS. Material properties are assigned to these are the material properties which are assigned to this model. After that, meshing is done. Here I have used tetrahedron type of meshing. These are the number of nodes and elements. As per the existing boundary conditions are selected for this. These are the model analysis results of the polyethylene material bumper. Here I have taken 6 modes for the investigation to determine the mode shape and respective natural frequency. A fixed support is applied at the base as per the existing boundary condition. In this analysis, total 6 modes are investigated to know the vibration characteristics of that bumper, and from each mode I am getting different natural frequency. These are the all results for polyethylene material bumper. Now I will go for fiberglass. Glass fiber composite material bumper. Same model analysis will be done for glass fiber composite material. These are the properties of that glass fiber composite materials. Now, the reason for selecting this glass fiber composite material is because we want lightweight design, and glass fiber composite material is it have low density and high impact resistance, also the high tensile strength, and it have good corrosion resistance. Now, same as like polyethylene material, meshing is done here. After that, model analysis. These are the results of model analysis of glass fiber composite material. Same six modes were investigated to know the vibration characteristics of this bumper, and I am getting increasing natural frequency from this. And I can say that increasing natural frequency shows that glass fiber composite bumper beam have high stiffness than the polyethylene material bumper. After that, manufacturing of that composite material. There are two methods of the molding: open molding and closed molding. Open molding is in this composite material is placed in open mold, and where it is hardened while exposed to the air. Tooling cost for this open molds is often inexpensive, and it is easily available. Closed molding is in this composite material process and cured inside the vacuum bag or two-sided mold close to the atmosphere. It is different from open molding totally. But it is selected for high production requirements. Here I have selected open molding method for composite manufacturing, and hand layup is a part of open molding. Hand layup, the reason for selecting the hand layup method is it is open molding method, and it is suitable for making wide variety of composite products from very small to large production. Production per volume of mold is low, but if we can make multiple molds, then it is possible for multiple production also. It is the simplest composite molding method, it's offering low cost tooling, and design changes are readily made in this. Also, here there are minimum requirement of investment, and also skilled operator can do the work in very low time rate. This is the process of hand layup method. First, gel coat is applied to the mold using the spray gun for high quality surface. When the gel coat has cured sufficiently, roll stock fiberglass reinforcement is manually placed on the mold. The laminating resin is applied by pouring or brushing using the paint roller. The FRP rollers are used to consolidate the laminate thoroughly, wetting the reinforcement and removing the entrapped air in this. The subsequent layers of the fiberglass reinforcements are added to build the laminate thickness. Low density core materials such as engrain and balsa, foam, and honeycomb are commonly used to stiffen the laminate. This is also known as sandwich construction. Now, experimental testing part. Here I have selected impact hammer test for experimental model analysis using FFT analyzer. The experimental validation is done using FFT analyzer. The FFT spectrum analyzer samples the input signal and computes the magnitude of its sine and cosine components. The advantage of this technique is its speed. And impact hammer impact excitation is one of the most common method which is used for the experimental model testing. This is the block diagram which shows the FFT construction of one model. This is the original bumper beam, composite bumper beam. Okay. Now I will go with the procedure. Initially, that picture is designed according to the existing boundary condition as per the FA results. FFT consists of impact hammer, accelerometer, and data acquisition system, in which each supply is applied to dash and laptop with DuSoft software to view the plot. Here I use DuSoft software for viewing that FFT plots. Accelerometer is mounted at the surface as per the high deformation observed in FA results, along with the initial impact of that hammer is placed for a certain excitation to determine the frequency of respective mode shifts. After the impact, FFT plots are observed on laptop, and the comparison of that FEA and experimental results are analyzed. These are the results of that plots, FFT plots of composite frontal beam. And finally, here it is the I have shown in one table the results of 6 mode shifts for FEA and experimental analysis. Finally, the conclusion. In this present investigation, first of all, the model analysis of front bumper, which is of polyethylene material, is done, and respective results are drawn as per that. In second case, model analysis of the same frontal bumper, which is made up of e-glass fiber epoxy reinforced frontal bumper, is done, and the results are drawn for that also. When we compare the results between these two, we can conclude that the natural frequency of the front bumper, which is made up of polyethylene, polyethylene material, is lower than that glass fiber composite material. Means for glass fiber composite material, it is increasing rapidly, which shows that glass fiber composite material have higher stiffness than polyethylene material, and it can be replaceable with polyethylene material, and it has restrictions to resonance also. From the experimental testing, it is observed that FFT results are almost similar to the composite frontal bumper, which are obtained by the numerical analysis. Hence, we can say that glass fiber composite is a good option for the replacement of that polyethylene material. These are the references of my topic. Here, base paper for my topic is first paper. In first paper, author have used carbon fiber composite material. In replacement of that, I have used glass fiber composite material. Okay.
6-7 steer axle drop test.
Hello.
Thank you.
Yes.
Thank you so much. Do we have any question from our chair?
Yeah, good afternoon.
Good afternoon, sir.
Yeah, can you tell me the properties of the epoxy that you have used?
Sorry, sir, I can't hear you.
Can you tell me the properties of the fiber that you have used, epoxy polymer that you have used?
Okay. Glass fiber epoxy polymer have good strength. It has high stiffness as compared to other composite materials. It also provides lightweight design, and it has good flexibility than the other composite material. That's why I have selected here glass composite material.
It has a low density too somewhere.
Yes, yes, it have low density but higher stiffness.
High stiffness. Okay, how you decided the nodes? You have divided the structure into 6 modes.
Yes.
So how you decided to take 6 modes?
Actually, I have referred one paper, means from base paper. I have decided to take 6 notes as per that author's experiment.
Okay.
Means with reference to that.
Okay. What type of cross section that you have considered while designing this type of frontal area?
Cross section.
Yeah. There are different type of cross section. If you know this, let me tell you. While designing the frontal chassis or frontal part of the automobile or any car, there are different cross sections depending on which the crushing or crash test can be conducted.
Okay.
So do you know what type of cross section you have used there?
No, actually, I have taken only experimental and FA analysis. The crash.
But you must have used somewhere bombardment from the frontal side, no?
Yes, bombardment from driver side.
Driver side, yeah.
Yes,
Of course,
yes.
vehicle crash somewhere, impact somewhere, it will have frontal impact. So there are different cross sections as per the current vehicle system. For example, open heart system is C rolled as well as open B. There are many closed B, etc., etc. So depending on that, you have to consider the parameter for the test.
Okay.
That's somewhere you need to work on. So what are the parameters you have considered while testing it experimentally?
What are the parameters I have considered while testing?
Experimentally.
Okay. Testing is done with the help of first doing the comparison of FA results of that polyethylene and glass fiber composite material bumper. And main parameters for consideration are it should be lightweight and it should vibrate less when some body impacts on it. This is the main parameter which is considered while designing. Also, it should have low weight so that it can help for fuel efficiency also. and strength of that bumper beam. Means after impact, it should not break, or it should not get people in the vehicle should not get harmed with that impact.
Okay, Mrs. I would like to add one more thing in your, I will say, thesis or a paper. While as I talked about the cross section, there is, if you are doing it with the software, there is a software called as a Creo. Okay, Creo can design the chassis using different cross sections. So if you can work on that, if you can use it for your study, it will be helpful. That's it from my side. All the best and thank you.
Thank you, sir. I will definitely try, Creo. Thank you, sir.
Yeah. Over to you, Ms. Edo.
Thank you so much. Let me call. Thank you for the presentation too. Let me call on the next paper. Paper design and experimental study on plastic metal hybrid used in automobile industry by Vinay Gopal Vyas.
Yes, hi. Good afternoon to all. I'm Vinay.
Hi, yes, I can hear you, but it's too low. Can you louder your voice?
Yeah.
Oh, there.
Yeah,
Thank you. You can go ahead and share your screen.
Yes, so I'm sharing my screen. Are you able to see it?
Not yet, almost. There you go. Go ahead.
Yes. So my topic is design and experimental study on a plastic metal hybrid, which we will be using in any structural part for the automobile industry. So my name is Vinay Gopal Vyas, and the two co-authors, which are my guide, Siddharth Raj Alkurkar and the Ketan Dhumal. So basically, let me introduce to myself. I'm basically pursuing my ME in design engineering from Pune University, and I have been working from last 8 years in CAE field. Right now, I'm an analyst in one of the Tier 1 automobile company. Basically, I have worked for designing and the FE analysis of interior and exterior automotive parts, like which are the front console, front and rear bumpers, front end module, automatic running boards, and etc. So basically, my experience is almost with plastic and less in metal parts. So what I'm now going to present to you is like nowadays we are learning, or we are hearing many things which is called hybrid materials. So to make a good hybrid material, I have just combining two different what I can say, two different materials, which is a plastic and second one is a metal. So why we are doing it? Because it will give us a good fact. Both we can use the both the technology, both the parts combining to one main hybrid, which will be called a plastic metal hybrid, and it will use the good way. And as for now, for my testing, I haven't used plastic as the injected molding. I have used as a 3D printing technology. So today's many companies for structural part, like any structural part like the A pillar, B pillar, C pillar, or some front parts, which many companies now are using a metal or the metal alloys for the good, we can say for the good structure, and like for strength, because they provide strength, rigidity, and energy absorption, and even for the weight reduction. So basically, I have constrained my what I can say, my idea to one of the part of the car or of the automobile. It's the front end module, which basically is at the front area of the car behind the bumper, which hold the headlamp, radiator mount, and other parts. So it basically, if we try to make a lightweight material in any automobile, so all the automobiles are now striving to reduce their weight by 20 to 30%. because it will surely give a good rise in the fuel efficiency, as well as the costing also get good. So what was my thinking before doing this thing, that what's the plastic metal hybrid? So whichever, if you can see, there is a one, this is a front end module part, which is always a front of the automobile or a car. So this part is basically usually are made of a metal, and now we are like introducing, like if you can see in second picture, it should be like a mixture, or on a metal part it should be having a plastic overmold. So for my study, I have done it like there's metal stamping, you can see at a U section, and then we have an injection overmolded part. So by combining these two technology, by these two parts, we can have a plastic metal hybrid. So why now the future is a plastic metal hybrid? Like always, everybody says that future is a plastic, but now some studies had shown that the future is a plastic metal hybrid. So you can, all of us knows that the metal has a high Young modulus, it's a high strength, it has a high elongation breakage, and it expands very less in a thermal, the thermal coefficient is very less compared to the plastic. And what do the plastic do is that plastic doesn't, it has a very less transfer of a heat. It always supports steel by using different technology. The main effect of the using a plastic is the density or the weight would be very less. And another importance now always know for the plastic are the complex designs are achieved by using plastic compared to the metal. So if we combine both this metal and the plastic, then we can surely increase, there's a high strength, the crash behavior of any structure would surely increase, and any thin wall steel structure like 1 mm or 2 mm thin wall metal steel structure, we can avoid the buckling easily by introducing the rib. And of course, one more main goal is to achieve a low weight part. So this all can be achieved by using a plastic metal hybrid parts. So what my plan was, it's to have a square cross section metal tube, which would be 1 mm thick and 50 into 50 mm square cross section area. So I wanted to study what type of rib pattern would be good for my future study. So I had one small wavy like a structure, and second there was a crisscross rib, and third was a honeycomb or the hexagonal structures like this. So I have manufactured the inner plastic by using a simple 3D technology, and the 2 mm thick, it's a 2 mm thick, and the material I used is the only ABS, means I haven't make it like composite of ABS by using another glass fiber or any carbon fiber. It's a ABS, only the ABS part. So the tube, in the tube, I have just placed or fit the rib structure. So basically I am making a static testing, that's a 3-point testing, which I have tested. So I have tested for all these 3 rib patterns, and to see that what would be the value we can achieve. And simply basic of the achieving a metal, like we say, metal is always strong, but when we go for 1 mm thick metal, it's always a flimsy metal. For large dimension, the metal will flimps, so that to support we need some ribs of a plastic, and this can be achieved by using a overmold part on the metal. But to the overmold part on the metal, like for me was very difficult, so I have decided for a 3D technology. because it was easily, prototypes are always made of by using 3D technology, and it was easy for me to do it for this condition. And so by doing a 3-point static analysis, I haven't done any dynamic analysis for the crash worthiness. I have done only a 3-point bending static analysis. So it was my zig, like if you can see the table, you can see that reaction forces, sorry, the stiffness for the honeycomb was 1.29x, which was very good compared to the zigzag or the cross. And we can say that the honeycomb structure is always good in static analysis for any other compared to the cross or the zigzag pattern of the rib. And to study the crash test performance, I need to do some dynamic analysis, and all I need some stuff or some money to be provided. So I haven't gone for any crash analysis for now, but for my further study, I will go for crash analysis for for using a FEA software, and then I will go for any crash analysis for the other thing. So only this was my presentation, and thank you.
Thank you so much. Do we have a question from our chair?
Yeah. Okay, what are the advantages of plastic over metal? Basic question. Then I will go to next.
Yes, so advantages is like the metal part. I can just show you if you can see this picture, the metal. So many companies, like many OEMs, are going for magnesium, okay, because the magnesium has the less density or the less weight compared to any steel part. So they are going for magnesium or aluminium to achieve that strength. But the cost is the another matter. And second is always the company wants from some new innovative India bag to show off to the customer. So they are going like a plastic metal hybrid. So always we know the plastic will not sustain or will not have that strength as of any metal. So they just want the combination of both. So what they are doing is they are making a steel structure or the metal structure.
Yeah, that we have already seen in your presentation. So
yeah, so they, okay, if you want to advantages, then the advantages is
no,
like
I already got it. I just wanted to proceed through that path. So I got it, the advantages. The next, I wanted to bring your attention to some of the disadvantages of this type of structures. What you can think about the electrical and thermal conductivity?
Yeah, the electrical and thermal conductivity, yes, of course, that there is an issue in thermal conductivitiness because the plastic at a high temperature will surely lose its strength. Okay, so that is why I have said that it should always use for the inner side of the like inner side of the automobile, not to the exterior, because the exterior will affect it.
Somewhere you use in the frontal side. That's why I was worried about.
Yeah, it was in frontal side. It was in frontal side, but it was behind the bumper.
Okay, because in the frontal side engine is there.
Yeah. So it's so it is like if you see this, there is one gap. Okay, so it is like for the radiator mounting. Okay, so the metal. So now by additives, by adding like glass fiber, or there are many additives. By adding that thing, we will increase the thermal conductivity or the thermal properties of any plastic. Yeah, but I can't do that because it has very
temperature ranges due to this type of structures, which restricts its use frequently.
Yeah, because if I can say you frankly, like if any plastic, if we go to 100 degrees Celsius, okay, its property surely degrades. But adding many additives, now the companies are adding many additives that are used for the bumpers, because we know the bumpers are all also nowadays of a plastic. So by using that type of additives, we are like increasing its thermal properties.
Okay, so somewhere you use the word of 3D printing.
Yes.
So which method you use there for 3D printing?
It's the SLM 3D printing.
Yeah.
Hello.
Selective laser sintering you are
Yes.
melting you said.
Yes.
Okay, that I wanted to know because when that is a concern again, when you use the additive, probably selective laser sintering will not work there because with that the hardness.
No. Yes, I can. If I am allowed to say something, is like I have used a 3D technology because I can't go for overmolded because overmolding was very costlier for me as from my side. Okay, so I used that technology which was easily available in Pune, nearby Pune, and it was what I can say pocket friendly to me because it is not like any company sponsored or something.
Yeah, that I truly understand with you and I agree with you. But whenever it will be in the mass production system, that time when you you talked about adding the additive materials, it will cause a restriction you
Yes.
somewhere my knowledge. Okay, and the last thing that I observed during the presentation, the deformation in honeycomb is larger. Somewhere you have shown.
Yeah, the reason the forces was also large. If you see, if zigzag had one, I just made a mistake here. Typo.
Yeah.
It was like stiffness. Okay, so like if you see the reaction, we were just seeing that we were applying a reaction forces, or you can say a force. So if you see it's a 100 Newton force we applied.
No, but why you varied the reaction forces? It should be same while you compare any system for its deformation. Then the action forces or reaction forces.
We were saying that the part should deform many. It should deform highly compared to the zigzag.
No, either you would have used the same, for example, 1.7x, and you would have checked the deformation for 3 models.
Because I know, I understand that it was my mistake that I did it. The force we applied was higher.
Yeah.
So I will keep in mind.
I hope you understand. When you do the comparison on the same platform, it validates the results.
Yeah, okay, that I understood that this happened wrong from my side.
Okay. Go ahead. Thank you. It's nice. And over to you, Ms. Jojo.
Thank you so much for that. And I'll be calling on the next presenter. The paper about new product design and development of sheet metal pulley with high load carrying capacity to sustain higher RPM by Pratik Chudari.
Hi.
Hi. Yes, I can hear you. You can go ahead and share your screen. All right, please proceed.
My topic is new product design and development of sheet metal pulley with high load carrying capacity to sustain higher RPM. This pulley we have manufacturing because over disadvantage over casting pulley according to company requirement we have manufactured sheet metal pulley here. My name is Pratik Chaudhary. My guides are Professor Maheshwar and Ketan Dhumal. My biography is I am Pratik Chaudhary, postgraduate student of engineering in mechanical design from Dhole Patil College of Engineering, Pune. I have worked on many industrial departments like manufacturing, quality development, new product development. I want to present my work on project on automotive new product development in future. For abstract for the our topic is basically pulley is manufacturing by sheet metal forming process. This is overcoming disadvantage or casting pulley. By sheet metal forming process, complex pulley can be easily produced and quickly we can produce that. Also, it is easy to manufacture part which are sufficiently strong and with high dynamic load and sufficient high accuracy. Sheet metal process have many forces to prevent product with high quality and short time delivery as a result of globalization market. Such process reduce cost and production time and production quality in future. problem statement. For overcoming the disadvantage of casting pulley, we have designed sheet metal pulley here. In this project, casting pulley is converted into sheet metal pulley. Uh, our main task is to work on following disadvantage. More weight of pulley due to fuel consumption is higher. Higher weight, higher fuel consumption, less load carrying capacity and RPM, and difficult to produce complex shape. Also in casting pulley, less surface finish, less accuracy in dimension. Overall cost of pulley in casting pulley is high as compared to in sheet metal pulley, and low production rate here. Methodology for the topic is the falling sheet metal pulley follows the falling process which are used. First one is the press section, then it will go to the welding section. Next one is the buffing, weighing section, spinning section, e-coating, CNC machining, and inspection, final inspection. Initially raw material strip or coil from stamping operation input, curve given to the welding, then welding operation will be welded curve is given in the spinning operation. The spinning operation group produce on OD pulley with the help of spinning stool. Spinning roller is used on roller as per requirement of customer groove geometry generated. This geometry is transmitted to the pulley. Basically, with the blanking in blanking section, when a component produced with a single punch and die with, we have produced a drawing is in the forming process in which sheet metal is stretched into the desired shape and actually drawn the pulley. Uh, Next one is the forming. The forming tool apply more complex from to workpiece. The line of bend curve instead of straight, and metal is subjected to the plastic flow and deformation. I have given some images here. This modeling I have done in UGNX software Unigraphics. This is a process flow for the sheet metal pulley. This is the actual model after blanking and drawing operation, and this one for forming operation. This one after piercing, after welding the bush and curve here. And the next one is a buffing operation to remove the burr from the sheet metal pulley. And next one is a pinning operation. Spinning operation is mostly the die form cup is placed on lower spinning tool. The auto cycles plumb button are depressed, and the tailstock start from down its return position, and tailstock approach rapidly until just above the part where it begin its control speed. When the part is fully engaged, the spindle starts the spinning. When speed switch indicates the correct speed to perform, roller start toward the part rapidly until it makes the contact fine speed cam. Um, Here for the spinning operation, we have approached the tailstock with 60 ton force, and bottom having lower spindle. Both at the middle portion we have placed the pulley. After that, there are two rollers, perform roller and finish form roller. From that we have applied 20-ton force on both sides. After that we have get desired shape for that spinning operation. We have done the APQP for this project, Advanced Product Quality Planning. Advanced Product Quality Planning is a framework for procedure technique used for the develop product in industry. Basically, in automotive industry, it is like concept for the Six Sigma. According to automotive industry action group, we have proposed the APQP to produce the product quality plan, which has supported development for the product or service that we have satisfied. Basically, in APQP involves there are different phases we have to consider for the development project. Mm. There are many groups are involved like process flow part, control plan, process failure mode, effect analysis. We have to take basic consideration before manufacturing of pulley. These are the die calculation we have done for the die designing of that sheet metal pulley. After that, modeling of press tool. This is a blanking and drawing die. This is a this modeling is done on CATIA. Forming process, piercing process, spinning operation. I have already explained the spinning operation. Uh, they the 60-ton force is from top, and this one is a steel stock, bottom is a lower spindle, and this one is a perform roller, and this is one is a finish foam roller. We have to apply the both side, this side and this side. We have to apply 20-ton force to mm, achieve the spinning operation exact shape on pulley. And secondary blanking process after the piercing operation. Final testing is the endurance testing for the pulley. The endurance testing for two pulleys mounted on the shaft with load. It rotates by basic RPM with some duration. Falling points need to be checked after and before testing. If pulley found okay within specification, then endurance testing is okay. These are the some condition we have to take into consideration. RPM is 4200, belt to wrap angle is 180 degree, load is 2 kg, cycle and duration is 100 hours. We have performed that at for testing condition. We have to consider the two pulley at first one is a top pulley and second one is a bottom pulley. This parameter we need to check and measure for a specific type, specific cycle and duration. Like poly V angle is 40 degree. We have to check with master sample. If we found okay, then our test within limit. These are the parameter we have to consider, like poly V angle, bore diameter, runout, OBD, and center line height. Conclusion is basically as per our results, the surface finish and high accuracy in dimension as compared to casting pulley here. Tolerance is 0.1 mm in sheet metal achieved without machining. With machining 50 micron, and casting pulley varies around 0.1 to 0.5 mm. To produce here, we can produce complex shape easily. Overall cost reduction in the pulley: sheet metal cost around 180 rupees, and casting pulley it will charge for 220 rupees almost. uh, Here RPM is improved as compared to casting pulley. Load carrying capacity also increase. The load carrying capacity for sheet metal pulley is around 2 kg, and with RPM of 4300. To reduce the weight of the pulley, in sheet metal pulleys, um, weight is around 0.6 kg, and casting pulley is around 0.9 kg. Due to difference of that, uh, these are the references for the project. Thank you.
Thank you so much.
Okay,
Question from our chair.
Pratik?
Yes, sir.
Very good work. It is your thesis work or somewhere?
This is my project work.
Of?
ME design.
ME design. Okay. Where you are working now?
I'm working in John Deere Technical Center, Magarpatta, Pune.
Okay.
As a design engineer.
Okay. One thing I would like to know you, what is the specialty or what are the features of casted pulley, you know? Why they are casted? Why they are not rolled or any other method used? Pulleys are why casted?
Mostly due to a cost situation, mostly the pulleys are casted only. Due to pulleys are used in mostly there are different applications like power steering, air conditioning pulleys, crankshaft pulleys, sleeve idler pulleys, alternator pulleys, timing sensor pulleys.
Okay.
They need to manufacture with less cost and with high load carrying capacity and to
Besides
sustain
that,
higher
besides
RPM.
that, they are casted because the centrifugally casted process are used for casting the pulleys, because pulleys need to be tougher at the core and it should be harder at outside.
Yes, sir.
Yeah, and that's why the pulleys are casted with centrifugal casting process. They are very tough. They are having a shock absorbing capacity at the center and they are hard at the outer rim. So is this property can be accommodated using sheet metal pulley?
Yes, sir. Here we have a higher RPM in pulley, also a high loading carrying capacity as per our testing. Uh, for endurance testing, we have done for this pulley in company. It will having load carrying capacity higher as compared to casting pulley, uh, uh, l- around 2 kg and with higher RPM around 4300. And also weight of this pulley in sheet metal pulley is less as compared to casting pulley.
Yeah, I know. Weight must be less because it is made with the sheet metal. What are the areas of application of these type of pulleys?
They are generally used in this actually pulley is for vane pump for pumping. Most of the pulleys are used in crankshaft pulley like sleeve idler pulleys, conditioning pulley. Most of the there are using power steering pulleys also.
The sheet
Power
metal
steering,
pulleys you are talking about.
yes. Power
Okay.
steering pulley with high pressure fluid is used to reduce high steering effort applied after by driver,
Yeah, but
or high pressure is fluid is created by the hydraulic pump.
okay. So in parameters, you mentioned somewhere poly V angle.
Yes.
Why poly V angle?
As per our requirement, this pulley is manufactured for the vane pump. As per customer requirement, they are using V belt there for the
Okay.
pulley.
So the angle will depend on the applications.
Yes.
Is this angle is going to affect the performance of sheet metal pulley?
I'm not definitely sure about that because this this is ongoing development project. We
Okay.
have not done any other development for that project, but in future we have to think about that for future condition
Okay. Thank you.
for
It's all
different
from my
application.
side. And all the best. All the best.
Thank you, sir.
Okay, Pratik.
Thank you so much. Thank you so much for your question from our chair. Let me go on and call the next presenter. Paper about a review on applications of nanofluids integrated to enhance heat transfer efficiency in high performance systems by Harshada Pulikar. Second call to the paper, a review on applications of nanofluids integrated to enhance heat transfer efficiency in high performance systems by Harshada Kulikar. Right. Let me call on the next paper about vibration analysis and topographical optimization of automotive sheet specimen by Mrutyunjaya Hirima. Am I audible?
Yes, you're audible now.
Okay. Let me call on again. Second call to paper about vibration analysis and topographical optimization of automotive sheet specimen by Mrutyunjaya Hirima. Okay. Let me call on the next presenter. Paper title about evaluation of propagation depth of critically refracted longitudinal waves in materials with finite element simulation by Vikas Divi or Dive.
Good afternoon, ma'am.
Hi, thank you. Yeah, good afternoon. Please go ahead and share your screen. Thank you. Yep, I can see it now. Please proceed. And by the way, can you louder your voice or please?
Yes.
Yeah, all right. Thank you.
Am I louder now?
Yes, you are. Thank you.
Okay, thank you very much. Good afternoon, all of you. I'm representing my research paper on evaluation of propagation depth of critically refracted longitudinal waves in a materials with finite element simulation. I am Vikas Dive. I'm representing with my co-author Sanjay Takde. He is my uh, guide for this topic. Uh, I am Vikas Dive, presently pursuing PhD from Pimpri Chinchwad College of Engineering, Pune, and working as assistant professor in mechanical engineering department at Dr. D.Y. Patil Institute of Engineering Management and Research in Pune. I have total 11 years of experience. I'm working on the funded research project from the ISRO University of Pune Space Technology SAIL. Okay, and my co-author has 29 years of academic experience and 4 years of industrial experience. He is working as a Dean Research and Development in the Department of Mechanical Engineering in Pimpri Chinchwad College of Engineering. Okay, so the abstract for these title is whatever the work we have carried out, it focuses on the method used to evaluate the propagation depth of a critically refracted longitudinal waves in the material. So when we are doing the measurement of residual stress in through thickness measurement, then it is most important to know at what depth we have did the measurement. So the these depth of the wave propagation can be evaluated by using the proposed method. So the critically refracted longitudinal waves are applied in the residual stress measurement because of the acoustic elastic effect. Okay, so simulations are performed by without performing the slot and without slot on the test material. Both the whatever the techniques I have used, experimental and the simulation technique, both the techniques work on the same methodology. I have used the ultrasonic transducers of 1 megahertz, 2 megahertz, 3 megahertz, 4 megahertz, 5 megahertz, and 10 megahertz frequency, having a diameter of 6 mm. And when I do the work, I come to know that the results of the simulation and testing, they fluctuate with the 1.35% of error. So whatever the methodology adopted here in this work can be applied to the different material used in the industrial application. Now, when we do the literature survey, after completion of the literature survey and by studying the number of papers, we come to know that there is a lacuna or problem in the depth measurement, and still there is a scope for improving the accuracy of the measurement. So the accurate measurement of the propagation depth can give a good result or exact result for the location of the residual stress in the through thickness measurement. So the errors in the measurement of wave propagation or depth measurement of depth propagation arises because of the imperfection of the groove machining, maintaining of the couplant thickness, and the case a stress concentration arising because of the machining operation while performing the grooving. So because of this, the error comes in the experimental, and that can be eliminated by performing a numerical simulation model. So we have developed the numerical simulation model for finding out this depth of propagation. Okay, so whatever the research work we have carried out, it concentrates on the using of the finite element numerical simulation on the test sample with and without groove. Okay, so the study has the effect. Study is extended to check the effect of the transducer element diameter, then wedge material, and the distance between the wedges, how it affect on the wave propagation. That also has been studied. So the material which I have selected is the aluminum 7075. The test material is the aluminum 7075, having the dimensions of the test sample are, it is a 50 mm length, 10 mm, it is in 10 mm thickness. Okay, the same methodology is adapted for experimental and simulation work. So here the basic principle behind the generation of the LCR wave, critically refracted longitudinal wave, is that we have to insert it in a oblique. So these first critical angle of refraction is calculated by using a Snell's law, which can give you the theta is equal to 27.45 degree for the aluminum material. By knowing the speed of the ultrasonic wave in the wedge material and the stress sample, we can find out this theta angle of refraction. Okay, then the here these ultrasonic transducer, one transducer act as a signal generator or signal sender, and the another transducer act as a signal receiver, and we have to measure the time taken by the wave to reach from this emitter to the receiver. Okay, and that can be measured with the function generator of the function generator and frequency generator. Then here the whatever the approach we have used, it is the using of the LCR waves that moves side by side of the sample surface. The LCR moves side by side to the test sample. Then the LCR, critically refracted longitudinal waves, they are having a high volume longitudinal wave that travel underneath of the material surface, and the frequency of this transducer depends on the propagation depth or penetration depth of the wave. Okay, then the diameter which we have used for the transducer, it is a 6 mm, material is aluminum 7075. Okay, then the excitation functions which is used to generate the ultrasonic signal or LCR signal, it is f of t is equal to 100 exponential of minus in bracket t minus 2 times of t naught divided by 0.5 t naught bracket square into sine of omega c into t. Omega c is f by fc, where the fc is the ultrasonic signal pulse frequency, t naught is the delay time for the ultrasonic pulse, and t is the time in second. Okay, so here if you see the different types of waves which are traveling inside the material, when we generate this input signal, and when the wave is allowed to travel in the wedge material test sample, the different types of waves are formed. So when these excited wave propagates from transmitting transducer to the receiving transducer, it goes into the series of mode conversion. So it converts into shear and longitudinal waves. So this is the shear wave we can see on the screen, and here we have the, at the front we are having the longitudinal waves. Okay, so the shear waves and longitudinal waves are called as the bulk waves. They are bred in the interior of the medium, and we are having surface waves also. They are called as the railing waves. They are called as the railing waves. Okay, and these railing waves may get vanished suddenly when they try to reach from sender to the receiver transmitter. Okay, so the transmitted signal mode conversion can be seen in this figure. So the shear wave propagates parallel to the railing wave. So this shear wave propagates parallel to this railing wave with the some lag. The railing waves are traveling faster than these shear waves. Then here you can see the bow shape leading wave, that is called as the longitudinal, and the wave traveling parallel to the wave propagation direction, means this is the wave propagation direction. So the wave which is moving parallel to the wave propagation direction and ahead of all these waves, this is ahead from all the waves, this is called as the longitudinal critical wave. So this is the wave which can reach the transducer first and it will give you the output at the receiver. Okay, to obtain the result accurately or to increase the accuracy in the result, we have set the time step equal to the mesh size, which is equal to 1/20th of the wavelength of the transducer, wavelength of the transducer. So by doing this, by putting this mesh size, we can obtain the accuracy in the result. Okay, then so the experiment and FEM simulations are performed on the different LCR wave travel time between signal transmitter and signal receiver transducer. So when we perform the experiment, these are the experimental results. The time of flight, measured time of flight, it is 8.65 microsecond. This is the time taken by the signal to reach from transmitter to the receiver transducer. Time taken by the signal to reach from transmitter transducer to the receiver transducer. And these are the time taken by the these are the time calculations obtained by using a simulation. So with the uh, simulation we obtain the 8.533 microsecond time for the first drop of the LCR wave. It can be seen at this 8.533 microsecond time. When we study the time property, it is possible to conclude that the LCR wave propagates faster than the other waves. From these two phenomena, we can say that LCR wave have the fastest traveling phenomenon. Okay, so here in both the experiment and in simulation, I have obtained the result by performing slot and without slot. So first of all, we have to record the reading with without this slot on the test sample, so that we can get the time taken by the wave to reach from this transmitter to receiver. And then in subsequent measurement, we have to put a depth of slot of width 5 mm. We have to cut the depth of slot on the material of 5 mm. Width is 5 mm and depth we need to vary. So that can be seen in the result table. If we see the result table for different frequencies, 1 megahertz, 2 megahertz, 3 megahertz, 4 megahertz and 5 megahertz, here you can see for the different depth we can obtain the different time taken by the wave, or it is called as the time of flight in experimental and FEM simulation. So here we have to carry out this uh, incremental depth in the material until the signal on the screen fades. Signal fades means it will become a flat. If you see this figure, so this is the original signal, means without slot. Without slot we are having this signal and these signals. And when we do the slot up to 5.82 mm depth for 1 megahertz frequency, the signal gets flat up to 933 microsecond. It gives you the first trough of the wave at this 9 uh, 9733.3 nanosecond. Means here we obtain the rise of time in the wave propagation. So because of slot we get the rise of time, and this is the concept. Based upon this we can see that the the wave propagation or the depth of the wave propagation is 5.82 mm. Means at what depth we get the signal fading, that depth we have to see, and that will be the depth of wave propagation. Okay, so like this, the measurements have been performed by using the different transducers: 1 megahertz, 2 megahertz, 3 megahertz, 4 megahertz, 5 megahertz, and 10 megahertz frequency. And the respective depth of propagation for this type of transducer are 5.82 mm for 1 megahertz, 2.77 mm for 2 megahertz transducer, 1.80 mm for 3 megahertz transducer, 1.32 mm for 4 megahertz transducer, 1.04 for 5 megahertz transducer, and 0.50 mm for 10 megahertz transducer. So from this result, we can obtain a correlation function between these two parameters, depth of propagation and transducer frequency. And that correlation is given by this equation: D is equal to 5.824 f raised to minus 1.07. So now the application of this correlation is that by knowing the value of the frequency, by putting this frequency value in this equation, we can find out the directly the depth of measurement of the wave, uh, or depth of penetration of the wave in the material. So from this relation, we can say that when we have the higher frequency transducer is used, a lower depth of wave penetration is recorded, or we can say that frequency is inversely proportional to the depth of wave propagation. Okay, so by knowing the depth, we can calculate the magnitude of the residual stress at that depth in the test material. Okay, now uh, to check the effect of the distance of the transducer, if we increase or decrease the distance between input transducer and output transducer, then how it will affect on the wave propagation. I have carried out the simulation. So here this slide will give you the representation of the effect of distance between transmitting and receiving transducer on the LCR wave propagation. So here the wedge is put in the material surface, and the study is used to check the effect of wave propagation or effect of change in distance on the wave propagation. So here when the distance is 30 mm, when we keep the distance between the two transducer is 30 mm, the time for LCR waves, the time for LCR waves. So the time taken between these two waves, it is the first of without slot, it can be seen at 8.5 microsecond, and with a slot it can be seen at this 9.7 microsecond. So there is a rise in time of 1.2 microsecond for 30 mm. As well as you can see there is a drop in the amplitude of the signal. If you have the distance between the two transducer as a 20 mm, or the two transducer are kept 20 mm apart, then the time taken by the wave to show the first trough of the wave is 8.2 microsecond, and its amplitude is 0.02733, and the time taken by the wave to show its first trough at 5.82 mm depth slot, it is 9.5 microsecond. So there is a rise in time of 1.3 microsecond for the 20 mm distance without slot and with slot as a 1.3 microsecond. So from this, what we can say that here you can see the amplitude of the LCR wave is slightly reduced with a decrease in wave propagation time, and there is a reduction in the length, or the reduction in the length reduces the propagation time by 3.3 microsecond. Okay, then next I have checked the effect of the transducer diameter on the LCR wave propagation. So the transducer is one of the most important component in the ultrasonic measurement. These transducers are made up of the quartz crystal working on the piezoelectric effect. So here certain factors affect this transducer performance, and one of the factor is the diameter of that crystal used in the quartz crystal used in the transducer. So the diameter of these quartz crystal forming the surface area of the transducer. So here the diameter of the crystal element has an impact on the beam spread. The diameter of this quartz crystal has impact on the beam spread of a propagating wave. So the beam spread decreases with increasing diameter. The beam spread will decrease with the increasing diameter of the piezoelectric crystal. So the selection of this larger diameter transducer will also decrease spatial resolution.
Hello, Vikas.
Yes, sir.
You have taken more than 20 minutes, beta, for presentation.
Okay,
So please conclude because others are there. They are in waiting lobby. Okay.
Yes, sir. Yes, sir.
Yeah, please.
Okay. So the last part is the wedge material, effect of the wedge material. Here also we get the rise in time of 1.5 for plexiglass and PMMA 1.2 microsecond. So the conclusion is that the work emphasizes to find out the effect of LCR wave propagation right below the material, right below the aluminum 7075 material. Then the experimental and numerical simulation result fluctuates with 1.35% error. Whatever the outcome we obtain or we get, that can be used for the selection of the that can be used in the further study as a guidelines in the selection of the measuring parameters and in the selection of the measuring devices. Then now the investigators can employ the calculated depth of wave propagation for determining the exact location of the residual stress in the test component. Again, this work can be give the valuable guidance for future study for residual stress measurement at depth with the numerical simulation. Or in future, the researcher may work on the effect of couplant between the wedge surface and test component surface, as well as the study can be extended to check the impact of transducer electrical and mechanical construction on the wave propagation depth. So this is from my side. Thank you very much.
Thank you so much for that presentation. Any questions from our chair?
Yeah, what are the factors those affect the refraction or propagation of wave in the material?
So the refraction will depend upon the density of the material, microstructure, then dislocation of the grains, and grain size. These parameters may affect on the wave propagation.
Can you tell me what is the surface or which is the body in which the highest or highest speed of propagation is observed? Wave propagation?
Air. In air, we can have higher wave propagation.
Yeah, I will add something. In vacuum, highest speed is observed. Instead of air, you can say vacuum.
Yes.
Yeah. So, have you sometime analyzed why there is what is the cause of parallel parameters between relic and shear wave?
Parallel
orientation
between railing and shear wave.
Yeah. What might be the reason?
Sir, shear waves, the angle because of the angle of incidence and the properties of the shear wave and railing wave. Railing waves can be seen on the surface of the material, that can be observed on the surface of the material. They cannot.
It is like eddy current. If you say compare with electrical,
analogy with the electrical
analogy, then it will be eddy current.
Yes.
Yeah. Go ahead. You are saying something.
So the railing waves or surface waves, they do not travel under the beneath of the material, and they are restricted to travel over the surface of the material. nearer to the surface of the material, means 0.1 micron or 0.2 micron, not more than that. And the shear wave, the second angle of refraction is a motive force in the formation of the shear waves, and because of that you can see the difference or lag difference between the shear wave and railing waves, and the
Okay.
shear waves are lagging as compared to railing waves.
Okay, so where is the highest speed you observe? It is on surface, subsurface, or at the core of the body?
The speed will remain constant throughout the either from it will be top or bottom. Speed must remain same.
Okay. Throughout the propagation?
Throughout the propagation from start to end, the wave speed will remain same.
No, I'm saying that, for example, there is a surface, so there is a block. If the wave is passing on the surface, then near the surface and at the larger depth of the surface, so the speed will be same?
Yes, sir, speed will be same.
Okay, what is the reason behind that? If you see eddy current passes faster at the faster rate, or current passes at the faster rate on the surface, or if you compare with the heat analogy, the conduction is more at the surface as compared to core. So why this speed remains same in case of wave propagation, or in case of electromagnetic waves, you can say?
See, sir, basic relation for the speed wave is if you go with the theoretical expression, it is under root rho on density of the material. Just
yeah.
Will depend upon the density of the material. That's why density remains constant throughout the either the material.
Yeah,
If
you already
if
gave answer in the first question that I have asked, because it will depend on the microstructure, it will depend on dislocations, it will depend on other material parameters, interior core. If those parameters will remain same, then the speed of propagation will remain same. If those parameters will vary, for example, dislocations are different at the different depth, then it is going to affect the speed of propagation, or what we call as a POF.
Yes.
Yeah.
But as the material density remains constant throughout the thickness of the material, it is not changing.
If it is isotropic material.
Yeah, for isotropic material, it will speed will remain same.
Yeah, for non-isotropic material, it will vary, my friend.
Okay.
Okay. Thank you. It's all from my side. Thank you and all the best.
Thank you, sir.
Okay. As the time exceeds, we have to start session 2 for this second day. So the two papers from this track 1, session 1, that is of Mr. Dattu Jagdale and Sandesh Sole Patil, we will transfer to session 2. I am very much thankful to Dr. Rakesh Chaudhary as he spared his valuable time for us and contribute his judgment to our session of ICETET-2021. Sir, really, we are very much thankful to you as you have spent a valuable time with us. And we hope that we will have a cooperation in future also. Thank you, sir.
Thank you, Swapnil. I'm very glad to see all the presentations in front of me. It has helped me to improve my knowledge too through these youngsters, those are presenting. Number of papers are there working on the CAD CA model. Somewhere they are working on some wave propagations we ended with, as well as some materials, composite materials. So these are the three regions what I observed during today's presentation. And I hope that these research will be carried out in further, and that will help them to get the new ideas and concept to be flourished. Thank you for inviting me, and all the best for all the presenters. I think 1, 2, 3, 4, 5, 6, 7 papers I have evaluated. I would like to ask the organizers whether I need to submit the sheet now or day after tomorrow.
Sir, please send it now.
Okay. So I will put the marks and then I will send it now. So you may have to announce the prizes for those.
Yeah. We are going to announce the best paper from each stream.
Okay. So I will send it now. Okay.
Okay, sir. Thank you.
Thank you so much for your time, Dr. Chaudhary.
Thank you.
And
Mr.
now let me welcome our next session chair, Professor and HOD of Modern College of Engineering, Pune, Dr. V.N. Chauguli.
It gives me immense pleasure to welcome Dr. V.N. Dr. V.N. Chaugule from Modern College of Engineering, Pune. It's our honor to have a session share like Dr. Chaugule. He has been rewarded PhD from SPPU. He has huge experience in industry as well as in academics. He has worked in Kirloskar Group, Aurum Machine Tools, and from last 20 years, he is working with MES College of Engineering, Pune. He is professor and head of department at MES College of Engineering. He has a huge research experience also. He has fetched a grant of rupees 20 lakhs from AICT under the model of proposal. He has been awarded with 3 patents on his name. He has also received BCUD research grant of rupees 1.5 lakhs from BCUD of Savitribai Phule, Pune University. He has several publications at international and national level. He has also participated in many national and international STTP, FTP conferences and workshops. He is expert in finite element analysis, CAD/CAM, numerical methods, and he also write down books on numerical methods and optimization and strength of material. He is also handling many administrative profile, and he is working as industrial consultants to many industries like Sukakarta Industrial Cluster. So a versatile, dynamic personality has been here to review the papers as well as judge the participant. So it's our great fortune that we have Dr. Chaugule with us. I request Dr. Chaugule to start the session, and I, Professor Prasad Kulkarni, on behalf of ICETET 2021, welcome him and request to start the session. Sir, please start.
Thank you, sir, for your nice words. I hope I'm clearly audible to you.
Yes, sir.
Yes, you are.
Yeah, thank you very much for confirmation. It's really a very tough time for all of us to interact online through online mode. It will be our pleasure if you could directly meet, but during this particular challenging period, we are meeting online. That's great, and I will request all presenters to follow the strict time limit of 10 to 15 minutes as given by the organizers. I must congratulate all the organizers for doing this kind of organization of this particular conference. Sorry, for this first time I'm doing this. Okay, thank you very much, and I will request you all to start the proceedings. Thank you.
Thank you. Let me now go. Once again, welcome, sir. And let me go ahead and go on the next paper about suspension-based power production for electric vehicles range improvement by Jagdali Datu. Yeah, I can now see your screen. Please proceed.
Good afternoon, everyone. The title of project is Suspension-Based Power Generation for Electric Vehicles Range Improvement. My name is Dattu Vasaib Jagdale. I am presenting this paper on behalf of my co-authors, Yogesh Chauhan, Akash Gaikwad, and Vikas Gaikwad. I am presenting this paper under the guidance of Assistant Professor P.S. Baravkar, sir. This is biography. I am studying in last year BE Mechanical Engineering from SND College of Engineering. My 3 co-authors are study with me. My guide is Mr. Pawan Baravkar, sir. as PhD scholar from Sandip University, Nashik, and he is currently assistant professor of Department of Mechanical Engineering in SND College of Engineering. Let's the abstract. Energy absorbed by shock absorber is dissipated dissipated in terms of heat. Thus, in this work, attempts have been made to convert dissipated energy in electrical energy. This project, we have used the heat generated by the suspension system. It is used for the generating the electricity, and this energy, this electricity is used for provide the vehicle to improve its running capacity. Introduction: the suspension system are used in vehicle to support weight of vehicle body and isolate the vehicle chassis from road disturbances. The specialized design of linear electromagnetic generators powers from the relative linear motion between magnets and coil. The second category is convert linear suspension vibration into oscillatory rotation and use rotational permanent magnet DC or AC generator harvest energy. This is block diagram of suspension. We have used bevel gear and rack and pinion mechanism for the for convert the vibration of suspension into rotary motion. Literature review: the research about energy recovery from vehicle suspension began more than 10 years, first as an auxiliary power source for active suspension control and later energy regenerating device in the own acro. Has presented innovative design of regenerative shock absorber which help to reduce impact forces and improve energy harvesting efficiency. It consists of unique mechanism called mechanical motion rectifier. It converts oscillatory vibration into unidirectional rotationer by Sanju MB. This is the references we have used for the paper. Review that the conventional vehicle suspension dissipate mechanical vibration energy in the form heat which considerable energy. Working mechanism: the vehicle moves over the speed breaker at height, resulting in increasing in kinetic energy. This kinetic energy can be harvested by using rack and pinion arrangement in regenerative suspension system. In this system, the linear movement of rack is obtained because of the compression and expansion of suspension spring. The rack and ratchet gears give positive motion, especially compared to the friction drive. The shaft is connected to driven gear with ratchet wheel. The result in rotation. The output of this shaft is coupled to a dynamo to convert rotational energy into electricity with the help of bevel gear. A vehicle loaded with 1000 kg going up height of 10 centimeter on such rough road produce approximately 0.98 kilowatt power. Working in this project, we have developed a suspension energy generation unit by using a rack and pinion method. It is less costly than the hydraulic unit. First, vertical movement of rack is in actual operation is happen due to suspension movement, but for experimental purpose, we give its movement by hard operation. Hand lever is pushed by hand. This pushing of lever result in vertical movement of rack attached to the suspension plate. This rack and meshing with it. On plate is mounted with rotate and same RPM opinion speed. Advantages of this project or this shock absorber have a great performance, handling and stability. They are for use with design 360 to prevent Asian and shock fade, improve range of electrical vehicle, improve dynamic stability of the vehicle, improve suspension ability of the vehicle, improve energy efficiency. This project has some disadvantages. This is not applicable for all types of two-wheelers. On smooth road, power generation is less than 4 volt. Design of the suspension system is not suitable for scooter. A whole system consists of electric wiring so that chances of short circuits. Application: all upcoming and all vehicles which are in use can be easily integrated with this kind of innovative technology. This system should be able to recover maximum amount of energy from the suspension and store system should be able to store it efficiently and use energy range regulation. Conclusion. Conventionally, the vibration energy of vehicle suspension is dissipated as heat by shock absorber, which waste a considerable number of resources. Power generating by shock absorber brings hope for recycling of waste energy. All types of power generating shock absorber, especially electromagnetic suspension and their properties are reviewed this project. The perspective of compensative performance, including vibration controllability, regenerative efficiency, and application reliability. With improvement of technology, power generating shock absorber may become one of promising trend of vehicle industry. Suspension based power production will be extremely helpful for electric vehicle to extend the driving range without investing lot more batteries. Future scope. The scope of for this project is that it is simple in construction and design and as low in price. It is specially mounted on the chassis of the vehicle and it produces 2 to 3 holes in even road and 6 to 9 holes in uneven road, which is sufficient for charging the vehicle battery when the vehicle is running position. This increase the efficiency of electric vehicles up to 10%. Further improvement in suspension design makes suitable for any two-wheelers electric by increasing the number of DC motor generating of power get increase which are used for high voltage battery. This system can be used on the mono suspension system by making suitable design. By modifying this system, we can implement this on electric car. Thank you.
Thank you, Dattuji, for presentation. But it will be my humble request to you all, or you can take it as a suggestion from my. One picture tells a story of 1,000 words. So in a presentation, I couldn't see any image or any picture. Sorry for being so critical with you for this. So kindly next time onwards, whenever you present, kindly present with some pictures or some animation. Because yeah. Hello.
Okay. Sir, because I'm out of town, then my mobile sir, मैं mobile पे कर रहा हूँ अभी इसलिए.
Okay, that's okay because we are facing say extraordinary situations. We can understand that, but kindly,
Yes.
don't expect. So literature you will read, and so the next person will understand that particular thing.
Yes.
So say, can you highlight me one important thing? What is your contribution in this particular presentation, or as a group? Actually, I am asking.
In this project, we have groups, sir. We are trying to improve the range of electric vehicles, sir.
Range of electrical vehicles.
Yes, sir.
Okay. So what do you mean by range?
Sir, company provides kilometer per charge. We are trying to do 10 kilometer or 20 kilometer for the 100 kilometer. For a 100 kilometer, we are charging the batteries.
Okay.
Yes. And then this recharging, sir. When the charger is regenerating the. Hello.
Please.
In this, sir, we are so there is network.
Hello.
There is network issue.
Okay. Please be careful with next presentation. Put more images, or you must be prepared for these particular situations.
Okay, thank you, sir.
Okay, thank you.
All right, thank you so much. Let me go ahead and call in the next presentation.
Yes, ma'am. Hello.
Yeah.
Hello. Sir, this is Arshal Patil. Actually, I am from a group which was going to present the effect of biofilter and use of it to treat the wastewater. Actually, our author is not there, so I will be like to present it.
Okay, please continue.
Hello.
Yeah, please continue. Yeah, please continue.
Sir, my name is Sandip Patel. I'm presenting my topic on review on developments and futuristic challenges in compliant mechanism under the guidance of Dr. N.R. Deve, sir. So I'm currently working as assistant professor in mechanical department in DIPMR Akhodi, and my area of interest is compliant mechanism and robotics. Basically, this compliant mechanism deals with the combinations of various beams and hinges. In case of some micro motion ranges, in case of some scanner, some lithography, in case of some biomedical applications, when you need to scan some images or when you need to scan some data, at that time we required micro motions, that is linear displacement along x and y direction, then along theta direction. So people are facing major challenges to develop that linear range of motion when you need to capture the images at some time of interval. Okay, so basically, if you look at this mechanism, compliant mechanism, it replaces joints with the help of some elastic beams. So when we are applying some forces, it will get deformed. Okay, so with the help of deflection or with the help of some elastic energy, or you can say strain energy, we can operate this system. Okay, so there are different mechanisms researchers have developed for various applications to get that intermediate scanning range. If you consider that laser sintering system, in that laser sintering system, we'll get X and Y range of motion when you operate that actuator with some forces. Okay, so with the help of some combinations of beams in parallel direction or in series direction, we'll get that range of motion with the help of actuating force and deflection. Okay, so various beams and various arrangements they have developed with the help of different degree of freedom, with the help of different length, with the help of different thickness materials, we can get different ranges. So purpose of this main development of compliant mechanism is the stability. We need to find out stability of mechanisms. So we need to identify its stresses, we need to identify its stiffness, we need to identify deflection, so so that the beam will not get warp, or we can say it will get only a single plane of motion. So when we are operating these beams for repetitive loading, or we can say repetitive period of time, it will get deformed in a different plane. Okay, so to avoid that deformation of beam in a different plane, we need to provide some arrangement which will make this mechanism more stable. Okay, so various platforms people have developed with the range of 1 micron to 100 micron, with the range of 1 mm to 6 mm depending upon applications. So these are the combinations they have used, combinations of beams in parallel direction, combinations of series and parallel beams to get that range of motion. Then these are the various arrangements we can use to operate that compliant system. Nowadays people are using some polymers to get that deflection. So major challenges in development of compliant mechanism is it has a limited range of motion, it has a parasitic motion, then there is a major challenging is in non-linear motion, we have to identify deflection when non-linearity comes into the picture, then fatigue failure of the beam, then coupling of elastomechanical and kinematic behavior, and serial parallel configuration. So these are the challenges which we need to consider when we develop new compliance system. We need to adopt these challenges, or we need to work on these challenges to get that better rigidity of that system and to avoid that in-planar or out-planar motion of that compliant beam. So people have used a different material like steel, aluminum alloy, titanium alloy to get that range of motion along X, Y, and theta direction. So major challenge when we are developing compliant system, you know, to identify stress and deflection, because stress intensity may get changed when we are applying parallel and series combinations of the beam. So at that time, you need to consider that material consideration for maximum loading and for maximum range of motion. So by using Castiglione theorem, we can evaluate deflection, we can evaluate elasticity. So moment equation of moment is m is equal to EI by double dash, that is second derivative. So with the help of shear force, with the help of moment, with the help of tensile strength and elasticity, we can calculate its range of motion and elasticity by considering different sections of mechanisms or different beams of mechanisms. So again, next parameter which is very important when we are evaluating accuracy and precision of the system, to identify or we need to select correct actuators. So in right now, people are using piezoelectric actuator and electromagnetic actuator for repetitive load and for repetitive operation of that system. So to evaluate that displacement, we can use this cantilever beam arrangement, because beams are connected and we can apply force with the help of actuator. So deflection of beam easily we can calculate by considering force, length, and elasticity. So L cube upon 12, yeah, that is the equation. If you replace I is equal to BH cube upon 12, you'll get that equation of deflection, 4F L cube upon EBH cube. Then sigma we can calculate by using that force, length, and area and its depth. Then yield strength we need to find out with the help of force, length. So first we'll identify deflection, then we can evaluate its stress value, then we can evaluate yield strength for different material, then we can evaluate maximum deflection of the beam with the help of that yield strength and elasticity. So these are the various ways to calculate stresses, deflection in that compliant beam. So conclusion from this review paper is, one can develop compliant mechanism for precise range, that is for small and large range of motion with the help of Castiglione theorem or that mathematical modeling. We can select actuators for that compliant system, and we can use that parametric design to operate that mechanism. So these are the reference papers which I have used for this mechanism. So thank you, sir.
Thank you. Thank you very much. Can you tell me, have you identified any problem in this domain?
Yes, sir. Currently, I am working with PI instruments. I have taken that biomedical scanner, and I have developed. I am developing that XY platform for that biomedical scanner with the range of 1 mm to 8 mm to get that data in biomedical strip. I am working with that PI instruments.
Okay, good. So approximately what size of equipment you are trying?
Sir, I have a platform of around 100 by 100 mm with a beam size of 10 mm and 1 mm thickness. I am currently using with beam size of 10 mm as the width and 1 mm as the thickness, and platform is 100 by 100 mm.
Okay.
And the required range of motion which they have given 1 mm to 6 mm.
1 mm to 6 mm, no?
Yes, sir. Along X direction and Y direction.
It is a fairly high. So why do you require compliant mechanism for that?
Because sir, currently they are using a system with the help of some controller, which is costly. The cost of that total available system is around 1.5 lakh. And if you apply compliant system, because the major problem which they have facing is image stability. For getting intermediate contents in that biomedical strip, they required large time. Okay, so to replace that, to get that data, they require every time they require different controller. So in case of compliant system, we are getting displacement with the help of beam deformation. So we can control the beam deformation. That is, we are using series and parallel combinations of beams. So we can use this beams deformation to get that intermediate travel range, and that is easily we can achieve with the help of that compliant system, and which has cost around 25,000, 20 to 25,000.
Okay. So almost how much project is complete right now?
So almost I have one setup I have developed. On that setup, I'm currently testing various ranges along X and Y directions.
Hello.
Yes, sir.
Yeah. I lost you.
Oh. Yes, sir.
I lost last part of your answer.
Can you please repeat, sir, what you just said? Just 2 sentences, because the chair was not able to.
Okay, sir. I have developed one XY platform, and I'm currently testing that XY platform for different actuation force. So I'm testing that platform for actuation ranges from 2 Newton to 50 Newton, and I'm currently testing that setups for different combinations of beams.
Okay. Thank you.
Okay.
Thank you.
Okay. Thank you, sir.
Thank you so much. Right, let me go ahead and call on our next presenter, the paper about manually operated fertilizer spreader by Sagar Sanjay Jaggi. Second call to the paper titled Manually Operated Fertilizer Spreader by Sagar Sanjay Jaggi.
Hello, can you hear
Hi.
me? This is
Yes,
Sagar.
I can hear you now. Please share your screen.
Yeah.
Hello. Hello.
Yes, sir.
Madam, before going to that presentation, myself, Mrityunjay, mine is just skipped because of some network issue. My serial number is 9, Mrityunjay G. Hiramat. Can I present
okay.
after this one?
Yes, I will call you after Jaggi's. Thank
Yes,
you.
thank you.
Okay, so good afternoon all. May I start?
Yes, please.
Yeah, so this is manually operated fertilizer spreader. So I am the author of this, and I have two more colleagues, my college friends, Praveen and Jagtap. And our guide was Professor Baravkar. This is a biography. Abstract, a method was generated to spread the fertilizer uniformly over a fallow land by dropping the fertilizer over the impeller disc. The system consists of 3 wheels, 2 at the front, 1 at the back. I'll show the diagram also. These 2 wheels at the front are used to impel the fertilizer. The 2 hoppers are used to store the fertilizer. These hoppers are placed at some height from the wheel axle so that the fertilizers, this condition is satisfied by the spring mechanism. In normal conditions, spring is not in tension and hopper is closed. As operator apply tension on the spring, controlling plate moves backward and hopper is open. Below this system, there is an impeller. It is mounted on the output shaft. Hopper opens on the impeller eccentrically, and due to centrifugal action, fertilizer spreads in the farm. This high value of centrifugal force is generated by the help of the proper gear reduction ratio. The gears are coupled to the shaft of the wheel. With this machine, percentage reduction in time required for fertilization was observed to be 50%, and reduction in the labor cost as compared to the conventional method was 80%. It has solved the problem of traditional way of fertilization. So this is the construction of my project, which we have made. So as we know, India is agriculture-based country. Near 70% of population of the country are farmers. Our economy also depends on it. Farming process includes many stages. So we just wanted to help our farmers by making this thing. The objectives, I will go. It is well known that by using farms equipment, farmer yield more crop productions, which ultimately have impact on national economy. Itself is gives prior need to agro equipment field of agriculture. These are some objectives. Fertilizer process should be less time consuming, portable, driven manually, lightweight, less cost, user friendly, eco friendly, and less fatigue to operator. So before planning this project, we just had a literature survey here nearby. This is nearby place to my hometown, Rahuri. So we just visited there and just have seen their tractor operator fertilizer spreader. It is mostly used in plain ground method of fertilization, as it is operated on pneumatic construction, which is complicated. It requires compressor and other accessories for its operation. Maintenance cost is also high, and tubing and compressor gets affected by soil particles. So not every farmer can afford it. So this is the construction of R1. It is based on motion of ground wheel using rear arrangement. The flow of fertilizer is maintained by using spring mechanism. It is a machine for spreading the fertilizer in continuous and controlled flow at uniform rate. It can cover an acre of farm within half hour. 3 wheels are used in this machine. Front axle 2 wheels are located to carry the load of the machine in a proper way, and last wheel used to balance overall load of the machine. First 2 ground wheels transmit the input power by the operator to the rotor by gearing arrangement. On rotor, hopper is located to receive a reservoir of fertilizer, of which flow is controlled by spring mechanism. The control of spring mechanism is under control of operator. This machine is operated using motion of ground wheel through gear transmission arrangement. The flow of fertilizer is controlled by spring mechanism. This is the construction constructional details. This is the big wheel, this is the small one, the hopper, this impeller, and this is the spring mechanism. Spring mechanism. The flow maintenance is necessary. Generally, every crop should get sufficient amount of fertilizer, so it is in our hands only. This condition is satisfied by spring mechanism. Flow control mechanism in normal conditions, spring is not in tension and hopper is always closed. As operator apply tension on the spring, controlling private moves backward and hopper is open. Main purpose of implementation nowadays, tremendous changes have occurred in conventional methods of agriculture like seed plantation, irrigation system, pesticides, and spray used. For developing our economic condition, it is necessary to increase our agricultural productivity and quality also. As we are used to do spreading of fertilizer in traditional way, which is time consuming, costlier, as well as not provide comfort to the labor. Also, some tractor operated machine for spreading of fertilizers are available. So what we need is an alternative to the traditional as well as tractor operators fertilizers. Spreading machine which will fulfill all the requirements. We can see today the major problem faced by the farmers is shortage of laborers, and also the time required for fertilization is more. So in order to have solution to it, it was proposed to manufacture a fertilizer spreader machine so the farmers can work more easily and functional. Like we are talking about farmers which are having less land in their part. Research methodology is based on the motion of ground wheel using gear arrangement. The flow of fertilizer is maintained by using spring mechanism. As I've shown, it is a machine for spreading the fertilizer in continuous and controlled flow at uniform rate. It can cover an acre of farm within half an hour, and 3 wheels are used in the machine. Front axle, 2 wheels are located to carry load for machine proper way to balance overall load of machine. First 2 ground wheels transmit input power by operator to rotor. This machine is operated using motion of ground wheel through gear transmission arrangement. The flow of fertilizer is controlled by spring mechanism. So these are some advantages: time saving, less fatigue to labor, high speed fertilization, applicable for small and medium farms, no electrical power required, easy to operate, easy to assemble, pollution free, and maintenance is at very low cost. It has we have limitations also for this. Machine requires more effort in hard soil. Operating force varies from person to person. It depends totally on laborer. Manually operated, so it is difficult to run continuously. So they may need breaks and all. So productivity is laborer oriented. Future scope to review major equipment operating and maintenance data for reliability, to review and find scope for process improvement for energy conservation, to identify the waste of fertilizer and recovery for effectiveness, to identify the scope of power consumption and estimate savings, preparation of action plan to implement the findings of study. Conclusion, our goal was to build a system which is efficient to perform various applications with the help of manually operated fertilizer spreader machine. With the scope of improvement, the project is done to fulfill the demands of agriculture applications. The main objective of our project was to fulfill the need of farmers suffering from the problems of increasing cost of fertilization, labor cost, and availability, as it is operated by a single person. It has solved the problem of traditional way of fertilization, since the capital cost is an essential factor by selecting type of equipment for farming. This machine has very less capital cost as compared to other types of machine, and also principal advantages of having eco-friendliness and easy troubleshooting. By undergoing all this discussion and undergoing all the factors associated with fertilization, this machine will be great boon for agriculture industry. So these are some references which I have taken. Abstract. Thank you.
Thank you so much. Question from our chair.
Thank you, Mr. Jaggi, for presentation. I think this is a more relevant problem for the agriculture point of view. And as an engineering students, we have done some work for that. That's great thing we can have, or it is a good output or outcome of this particular node. Zach, one important thing I would like to ask you: how many units you have prepared or manufactured?
This is only, actually we have done this for our project purpose. So this is only one we have prepared.
Can you tell me what are the specifications of that machine?
So constructional details I have shown, so that are there
Specifications,
in
like
my
I want to say how much fertilizer it can take at one time.
sir, this is like it depends upon size of our hopper. So that also we have to do manually only.
But how much? What is the capacity of that machine?
Sir, we can increase the size of hopper, and so
No.
actually this hopper which we have used is a bucket size.
Your machine. What is the capacity of your machine?
Sir, it can spray up to like 10 to 15 liters we can add. Depends upon its capacity.
So it is in liquid stage or solid?
Yes, liquid stage.
Okay. Okay. And how you are controlling that?
Sir, with spring mechanism, like
how you control?
it will be in hand.
Looking at construction, it appears like it is spreading granules of fertilizer.
Sorry?
Looking at the construction, whatever second slide you are shown, it appears
Yes.
like spreading granules of fertilizer.
Yeah, no, but we have made this for fertilizer to spray.
Yeah,
that.
fertilizer. But what is the state of that particular material? Fertilizer. It is liquid
Sir,
or
it will be liquid, sir.
Solid, sir. Sagar, this is solid.
it is the solid granules, sir?
Solid. Solid. Sagar.
Somebody is answering. Praveen is answering.
Yeah, Praveen, you can answer directly what you want to say.
Sir, this is not liquid, sir. Solid purpose. They are also liquid, but the construction is different.
Okay. So, what kind of fertilizer you used for this?
Sir, like urea. Urea, NPK, sir.
Okay.
Nitrogen, potassium, and
that's fine. I was just checking how much you are really involved in the project. Thank you. Thank you. We can go for it. Thank you. Thank you. Next.
Thank you. Thank you.
Right. Thank you so much. Now, let me call on the paper about vibration analysis and topographical optimization of automotive sheet specimen by Mrutyunjaya Hirimath.
Yeah, thank you.
Thank you.
Let me share my screen.
All right, I can now see your screen. Please proceed.
Yeah. So, good afternoon, everyone. Myself, Mrutyunjaya Hirimath. Today, I will be presenting on vibration analysis and topographical optimization of automotive seat specimen. So, under the guidance of Professor Maheshwar sir and Vikram Bhagat sir. So, yeah. So, about myself, I am second year PhD student studying in Dole Patel Engineering College, Dole Patel engineer. So this project is a part of my academic activity, and also I'm working professionally in one of the company in Pune, engineering service company in Pune. So basically, the topography optimization is a special class shape optimization which can be used to change the shape of shell structure by introducing stamp V for the better structural performance. So basically, what I'm trying to do here is we're taking a sheet metal, a specimen, and trying to improve its strength where it has used as a structural component under which various loads. So basically, it's we can call it as a skid plate. So for the scope of project, I am using the skid plate. So skid plates are generally used for absorbing the vibrations and dampening the control the damage of the vehicle. So basically those are used below the vehicle where the engine is mounted or any important components are mounted. So there it is used. So so here, like for this project, I created a 3D model and used the ANSYS to perform various analysis. Yeah. So I'll go to the next sheet. So basically, yeah. Yeah. So the introduction is like the structural designs are generally are subjected both to both performance requirements like the strength and stiffness and cost constraints. So thus it is important for concept design to account minimum weight structure with a maximum or optimum performance given in a set of constraint. So so beads are a widespread technology. So basically, we are using a beads, sheet metal, so that to improve the stiffness. And the two main application of a bead technology are to increase the stiffness for static loading condition and to reduce the noise and vibration for dynamic condition. So however, it is difficult to design the bead pattern of sheet metal structure due to the directional control, the reinforcement effect of the bead. So a wrong pattern bead pattern layout can weaken the properties of the structure. So it is important to also control the pattern. And so the sheet metal plate structure are used in many engineering applications for various objectives, more specifically many machines and vehicles. And need sheet metal plate in other outer cover. So it's also used in many outer cover for the outer, protecting the internal components. So they are the and also they are the one main source of the noise due to their relatively poor hindering the propagation of the elastic waves in their in terms of in the time of excitation. Okay. So here the problem statement is like the sheet metal components are the major cost drivers, because if you increase the thickness and size and also the method of manufacturing and the tooling cost will also add up. So because of these conditions, the sheet metal components are basically costlier. Sometimes even though if you try to add stiffeners and beads, that would also increase the tooling cost. So so to perform topography optimization on the sheet metal specimen, so that by reducing the weight thickness, also improving the stiffness. So we are trying to perform topography optimization to improve the overall strength of the sheet metal without increasing the cost. So the scope of this project is to model sheet metal specimen. So here I have used a CATIA 5 software and analyzing the stresses and the deformation in the sheet metal specimen under static and also the vibration condition. And topography optimization for the sheet metal model, and perform a model analysis of optimized model for finding a natural frequency, and to perform experimental testing of a new optimized model by using FFT analyzer and impact hammer test. So, and finally, we will compare the experimental test and correlation the results. So the steps involved here are basically I have started the project with a literature survey to find I found some similar topics and similar testing were performed, and then after that I have identified what type of components are required during the project testing and analysis phase, and created a 3D model with the help of CATIA, and did analysis with the help of ANSYS, and then experimental testing, and finally comparative analysis between the ancestry and experimental result. Yeah. So for this current study, I have used structural steel, which is EN 1993 material. And this is what I have prepared a simple plate for the comparative study. So basically, what I have done is I done a comparative study between simple plain sheet and then done a comparative between a B stamped sheet. So the size of the both sheet would remain same. So I have taken 300 and 300 into 3 mm size sheet. So basically, I have done two patterns. One is 6 into 6 pattern, and one is a 4 into 4 pattern. The size will remain same. But the bead size for both the 6 and 4 pattern will remain same. The size of the bead will be, the maximum inside diameter is 10 mm, and the corner radius is around 3 mm. Yeah, the bead height would be around up to 5 mm. Yeah. So for the plane, we have done I have done ANSYS machine using a plane sheet. So with that, there are 25,800 nodes were generated for a simple plane sheet, and also did model analysis under 6 frequencies. So in that 6 frequency ranges, for frequency range of 295.34 hertz, I found the deformation up to 53 mm maximum, and for the maximum frequency range 1072 hertz, it was around 65 mm. Similarly, I have performed model analysis for 4 bead structure, 4 into 4 bead structure, and also similarly performed for 6 into 6 bead structure. So here also I have captured the deformation in terms of mm. For first one, it is around 46. Sorry, the maximum around 52 mm, and for the 6 pattern, at the maximum frequency, it is around 65 mm. And also after the model analysis, we have performed static analysis. So in the static analysis, the first one is performed for the plane sheet for maximum deformation of 1 mm. The amount of reaction force is calculated. So here, the boundary conditions all around the edges, the boundary conditions are considered for the edges. For this also, the boundary conditions are considered for the edges. So yeah. So here, here for this plane sheet under 1 mm deformation, the total reaction force was captured around 1032 Newton. And similarly, for 4 pattern, the reaction force is around 1070 Newton. And also same, I have performed it for 6 into 6 pattern, that is coming around 129 Newton for force reaction. After after the ANSYS simulation results, I've also performed impact hammer testing for 6 into 6. So here, we have performed, we have used a model hammer and accelerometer used. So so model hammer, which which calculates the amount of force given, and then with accelerometer we have calculated, we have recorded the acceleration with respect to the frequency. So this is the graph which is the outcome of that testing. Yeah. So the results and result of this testing is, we can see like in existing mode and sorry, the simple plate and the 4 pattern, and with the 6 pattern, with the various mode shape, there is a variation, like there are different level of frequencies are coming. And in the present result, the flat sheet metal and sheet metal with the stamping have been analyzed. So in FEA to determine the reaction force for a particular displacement. So it is observed from FEA that the reaction force for the sheet metal with the stamping is greater than the existing flat sheet metal. So with this comparison, like we can see that the pattern, the bead pattern would definitely improve the strength of the sheet metal. So this is the, just the comparison between FEA and the testing. With the improve, we can also see in the static analysis, like with the help of beads, the strength is improving, the reaction force is improving. This is just for comparison. Yeah. So yeah. So this one, this comparison is in under different mode shapes, with with the simple plain sheet and with the 4 pattern with 6 pattern. What is what is the strength comparison? So so conclusion here is, by performing the modal analysis on skid plate to find out reaction force in the vibration condition, to find out the fundamental frequency of the plate. To improve the frequency of the skid plate, use a stamping method on the plate to perform modal analysis to find out fundamental frequency. The fundamental frequency of the existing plate is 292 hertz, and by stamping 4 pattern frequency is improved to 296. Again, with the 6 pattern, you can say, like you can see, like it is improved to 299.94 hertz. So in again, like in static analysis performance, to find out which is the best, you can see, like with a simple plate, we found 1032 Newton. With the 4 pattern, it was coming around 1070 Newton. And with the 6 pattern, it is almost increased up to 1129 Newton. Yeah, that is from my end. Thank you all.
Thank you. Question from our chair.
Thank you, Mrutyunjay, for presentation. Can you tell me what is your objective of this paper?
Objective of this paper to improve the strength of the sheet metal with having a bead structure, so that without increasing the thickness of the sheet metal or adding any extra weight to it. So to improve, basically to improve the structural strength of the machine.
So you want to increase the structural strength of it.
Yes.
Now tell me, how much you successful to identify that? Because as I can see, the model frequency just changed by 2 to 3%, if I'm not wrong.
Yeah, I also found that it's very for this study, I used a particular bead due to time constraint. I was not able to do much study much to check with the various sizes of a bead. But looks like if we improve the size and shape of the bead, maybe we can go higher. But currently, with this bead size, I'm able to achieve only very less, we can say, improvement.
Okay. And one more important issue. Say you are doing modal analysis for the plate. Huh?
Yes.
How that plate is constrained?
So currently, the boundary condition is around all four edges. So we are holding it tightly in all four edges.
Okay. So what results you got?
Sorry.
Results.
Sorry, I didn't get you. Can you repeat?
Results. What results you had?
Result in the sense like for structural with the structural in static I found like
No, I'm asking about in model.
Oh, sorry. Yeah.
You got something 300 and 610. Okay. More shifts. Okay. Any applications you are eyeing on?
Currently, like not specific any applications, but I'm thinking like we can use in wherever there is damping or vibration forces are there. Like I found like one of the study was made on a skid plate, which is used under the vehicle. So for that, like we can use it.
Okay. If you change your holding positions, you change your constraints, then model shape will change or it will remain same. So instead of binding that particular skid plate on both sides, if I change that particular constraint.
I'm assuming that would change because in that case, like my plate won't be the same because I have some support. For example, if you give a support in between, that mode shape definitely would change.
Okay. So you are going to get same frequencies or different?
I'm not sure, but I'm guessing I would get different frequencies.
Okay. 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 Thank you. Thank you.
Yeah, thank you.
Thank you so much. And I'll be calling now the next presenter, the paper about modification in mini CNC machine using Arduino by IFERP Ambavale.
Hello,
Right, I can now see your screen. Please proceed. Hello? I cannot hear you.
Hello.
There you go. Proceed.
Yes. So good afternoon. We are the students from MIT Academy of Engineering, Pune. And the topic for the paper is the modification in mini CNC machine using the Arduino. So myself, Athar, and my teammates are Pranit, Sushant, and Shantanu. And we are working under the guidance of Professor Priya Patil, sir. And we are basically from direct second year students. So these are some of the contents that we are going to present today. It's the introduction, objective, literature review, requirement analysis, simple project scheme, the circuit diagram, the methodology of the working, application, advantages, future scope, and the conclusion.
Hello, Athav, can you hear me?
Yes, sir.
It will be better if you can directly go to your objectives and discuss what you had done.
Okay, sure, sir.
Please.
So these are the objectives. The objective was to develop a mini CNC machine with the help of the Arduino that can draw the diagrams as well as emboss letters and patterns on any surface. And this is basically a multi-purpose CNC machine that can be used for the educational purpose as well as for the small industrial applications. So these are the problem segment that as we see that the CNC machines, they are quite costly and they are not suitable for the small jobs. Therefore, it was necessary to build a mini CNC machine that can be used for the demonstration purpose. So Pranit?
Go to the requirement analysis. Okay. Yes. Hello. Good afternoon, sir, and good afternoon, all present here. So basically, the requirement analysis for our projects are some hardware requirements are stepper motors for the movement of the bed in X and Y direction. Then it requires L29 3D motor shield to control these motors, that is servo motor and stepper motors, and also control the speed of that. Next is the Arduino Uno. It is the main heart of our project. Next we have used the DVD drives Next, some software requirements that we require are Arduino IDE software in which code is given and the CNC machine will work. Next is Inkscape. Inkscape is software in which any image or any letters can be pasted and we can get the G code from that. And Chemotics is the software in which we can print any software, any drawings, any letters, etc. Virtually. Next. So it is this so simple project scheme. So I will tell the overall about the project. First, we have to upload any image in the Inkscape. Then it will create the G code. From that G code, we have to send this G code to the processing software, which will send that G code to the Arduino. After that, Arduino will request the CNC still to control the movements of the motors, and we will get our output. Next.
Hello.
Yes.
So what is in the circuit diagram? There are the two motors that are stepper motors. First one will control the x-axis and the second will control the y-axis. Then it is connected with the motor shield. The motor shield is then connected with an Arduino. So the x-axis is controlled by first stepper motor, the second is controlled by y-axis. Okay. Then the z-axis is controlled by the servo motor. Okay. Then we will see how this system is built in our model. So the first the x-axis is mounted on CD drive 1, which is grounded the best. We have fabricated the columns, vertically columns. Then the second DVD drive is mounted on that, which controls the y-axis. After that, the servo motor is mounted on the end effector so that we can control the z-axis. In this way, the three axes are being controlled. Okay. So next slide, please. So we will see the methodology. So first we have gathered the components which are being required for our projects. Then we have assembled the components by their specification usefuls. Then we have wired the all components together as the requirements are being discussed in circuit diagram. Then the Arduino code is been taken. The Arduino code is, as the Pranit has explained, how the Arduino code is been taken. The G code is been taken from the software. The Atharva will explain the proper view how our image is being formatted in G codes. When we take any image from source, it may be a sketch or it may be an PCB designing circuits. So we get that imports in Inkscape. Then Inkscape will give us G code files. Then G code files is being imported in our software, that is Comedix. Then the Comedix will process to the Arduino. Then Arduino will give you a final output. It may be engraving or our PCB circuit design. Next slide. So this is Inkscape interface. Here we can import any sketch or any image or any design which have wanted to output our output. So what we do in the software, we just import the image and convert this image into G code files. So Atharva will just Atharva, you can show the demonstration of this.
Yes, Chandanu. So this is basically any image that we can get from the end source, such as Google and anything. So we just need to copy this image, and this is the Inkscape software. So we can just paste this image over here. After pasting the image, just drag the image over the center. Adjust the image according to the edges of the software. Once we adjust this image, just go into the object and just go into the path and just press the bitmap. It will just create this slide. After that, we can see that there is a edge detection and color quantization, and we can also see it is available in the colors, or we can see it in the black or white software. So now we'll take the color and update it. We can just see the replica of the image over here. Once we click on the OK, we just close the slide. We can drag the image over. We just get a replica of the image over the side. So now we can delete the original image that we have got from the source, and we can now drag this bitmap image over the center of the interface. After doing this, we again need to go in the path tool and just give the dynamic offset. After the dynamic offset, just select the map. We just get all the coordinates. After the coordinates, just save the file. While saving the file, we just need to do in the .g code form, because in the Chemotics it just accepts the .g code format. After doing, we also get the code over here. Now we have the available code over there. Now this is the Capotic software interface. In this, we just need to open a new project. We already get a G code format, G code file of the product that we are doing. Just select the code and enter the code. The code automatically gets placed into the software, and we can see that the image that we wanted to crave is available here. And we can also start the simulation. So this is how we get the simulation of the actual product that we wanted to carve on the surface. So Shantanu, you can continue.
Okay, so this is the Inkscape. Then this is the G code as otherwise explained. Then the Camotics, and this Camotic software is being explained. Then the next slide will be explained by Sushant. Sushant, you can continue. Sushant,
please continue.
Yes, so moving towards the application part. So these are some of the applications of the mini CNC machine. Basically, it is a multi-purpose CNC machine that we can use in different sectors, as for in the industry as well as in education purposes for the demonstration purpose. So here we can see that it is used to crave the embroidery or the designs on any surface, so that we can use it as the decoration purpose or anything. Also, we can use it in for the demonstration or the prototype creating purpose. So these are some of the advantages. First of all, it is very easy to use. That is, it can be used. It can be used by low skill operator. The next one is the operation is quite reliable. That we can trust on the product that has been developed. Moreover, it is cheaper, as I have said earlier that the conventional CNC machine that is used in the industries. First of all, it has high cost, and moreover, if you want to manufacture any small job, so it is not possible and it is not cost worthy. So in the case of manufacturing the small jobs or in the educational purpose to demonstrate the use of the CNC machine or how the CNC machine works, it is useful in that case. And so these are some of the future scopes. That is, now we are using the pen to draw on any surface, but later it can be used by the laser to carve on the surface also, we can replace the pen with a powerful drill so that we can make patterns on the surfaces as required. Then more on the servo motor, it can be replaced the stepper motor so that we can mount the 3D printer on it. So this project, it can also be shifted to a 3D printer by just shifting the servo motor over the stepper motor. Then is the PCB writing, and it can be also used for the wood cutting operation. As we said that the wood cutters are also quite costly. So in this case, if we use a proper tool on this machine, it can also be used for wood cutting. So Pranit.
so we can conclude that our CNC machine that has been manufactured, it has been best way for small scale industries. As we know, the CNC machines price, it is high price, high costly. So we can afford this CNC mini CNC, and it have very many useful things. As we change the end effector, like we give the end effector as a pen, then it will be draw some particular design or drawing. If we give the cutter, it will be get included in cutter. Then if we give the 3D printing pen, then it will be 3D printer. So it have the multiple uses. By the multiple uses, also we can design the PCB circuits by this mini CNCs. Okay, thank you, sir.
Thank you. Question from our chair.
Thank you very much. Atharva, you are students from second year.
Yes, sir. Direct second year.
Yes,
thank you.
Direct second year. So I will appreciate that you have taken this particular project. I hope you had manufactured this model, CNC model.
No, sir. Actually, we have just gathered the component because of the pandemic. Actually, we are not together, sir. So because of pandemic, it was not possible to manufacture it. But as now, just we are gathering the components, and we will soon manufacture it, sir.
Okay.
But the simulation is ready, sir.
Yes,
We see in Camodix.
Okay. Okay, then it's okay. Now, I hope you are. Sir, can you tell me how that this kind of resources are already available on DIY kits or DIY sites? Do it yourself. So how it will be different from that, or you are referring the same?
No, sir.
No, sir. It will be completely different, sir. In that case, sir, they just use to write or draw with the pen. But sir, in this case, we can also use a probe, or also, as I said, that we can also use the laser to crave on the surface. Means we can emboss or carve patterns on the surfaces.
Okay. 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 Thank you. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
All right, thank you so much. Let me call on the next presenter. The paper about design of cutting machine and improvement in rejection and foam machine by Kunal Shindi.
Participants are present from this group.
Right, second call, design of cutting machine and improvement in rejection and foam machine. All right. Let me call on the next presenter, design and modeling of die threading machine by Subham Samadan Agale. Second call on paper about design and modeling of die threading machine by Subham Samadan Agale. Let me call on the next paper about optimization of process parameters in turning operation and use of RSM for design of experiments by Dr. N.L. Birud. Presenters, please listen very carefully. I'm calling second call on paper optimization of process parameters in turning operation and use of RSM for design of experiments by Dr. N.L. Birud. Right. Next, I call on the paper about solution of one-dimensional linear convection equation using different finite difference method by Professor Kiran Moore.
Participants are present from this group.
Yes, sir.
Shreya,
Right.
are you going to
Please.
present or should I play video?
Sir, can you play the video?
Okay.
Okay.
Saugale sir. Hello.
Yes, sir. Yes.
Actually, from this group, they just prepared their videos. I'm just going to play that video, and after that, the students are going to answer the questions.
Okay. Okay, sir. Okay.
Yes, please go ahead. While we're waiting, I would like to remind everyone that we will award by the end of all the technical sessions. We will gather back here in the main room to award the best paper and best presenter. Is the video available, sir? Can you share your screen?
Now it's visible to all.
I'm waiting.
So it's visible to all.
Not yet. There, it's already available. Please Play the video.
We have done a research, and title of research is Solution of One-D Linear Convection Equation using finite difference scheme using MATLAB. In this research, there are 5 authors. First, Mr. Kiran Dimore, Mr. Sohail Tadvi, Mr. Shreyas Taide, Mr. Rishi Jhage, and Mr. Swapnil Deshpande. So, by starting with the introduction, the fluids are essential part of our existence, from breathing air to drinking water, from cricket to football, from racing to air travel. Our interaction with fluid is inevitable for our living and survival. Therefore, it is essential for us to understand how this fluid works and able to predict and simulate how they behave under concerning circumstances so that we can make them work to our advantages. That is where CFD comes into the picture. In this, we studied dealing with the solution of wave equation. With the help of MATLAB software, the wave is represent the partial differential equation. With the help of research, we are going to utilize the MATLAB partial differential solver to solve 1D linear wave equation by using different finite difference scheme. For technical computing, MATLAB is considered as high performance language. The performance is better when we solve a wave equation using MATLAB instead of using manual method in terms of speed and accuracy. Therefore, MATLAB is considered as a high level programming language. Literature review. To get the specific information about our research, we have studied the previous published work on our topics, and the overview of that published work is being added. Wave equation. We have 1D linear convection equation, which is du by dt plus c into du by dx. This equation represents the propagation of wave with respect to time and space. So we need to discretize the wave equation. Discretization is the process of transformation of partial differential equation into a set of algebraic equation. Here we are used finite difference method scheme. In finite difference method, there are various types like forward, backward, central discretization. So we are applying these schemes one by one. Here we discretize wave equation using forward in time and backward in space. So we get following results. That is du by dt is equal to u2 raised to n plus 1 minus u2 raised to n upon delta t, and du by dx is equal to u2 raised to n minus u1 raised to n upon delta x. By equating and simplifying both the equation, we get u2 raised to n plus 1 is equal to u2 raised to n minus c delta t upon delta x into u2 raised to n minus u1 raised to n. Here n plus 1 represents the present time and n represents the previous time. The same sample wave diagram represents the wave is moving from left side to right side and shows the distance between the two grid points is delta x. So we write a program for forward in time and backward in space. So by running this program, we getting a plot, we can see that the wave is moving from left side to right side and the square shape of the wave is maintained. Hence the scheme gives a stable solution. Here we write a wave equation using forward in time and central in space. This is another method of finite difference scheme. We can say that the first derivative, which is du by dt, is discretized by using forward in time, and du by dx is discretized by using central in space. After equating and simplifying both the terms, we get a result which is u2 raised to n plus 1 is equal to u2 raised to n minus 0.5 into c delta t upon delta x into u3 raised to n minus u1 raised to n. Here we write a program for forward in time and central in space with. Here we used updated discretization equation. After running this program, we get a result which is not as per expectation. The wave is blows up and hence the scheme becomes unstable. Here we again discretize our wave equation using forward in time and forward in space. Here we can say that the first derivative, which is du by dt, is discretized by using forward in time, and du by dx is discretized by using forward in space. By equating and simplifying both the terms, we are getting the equation which is u2 raised to n plus 1 is equal to u2 raised to n minus c delta t upon delta x into u3 raised to n minus u2 raised to n. Here we write a program for forward in time and forward in space. This program is almost same as per the previous program. Only difference is here we use a different method. So by running this program, we get a result which is not as per expectation, and again the solution blows up, and hence again the scheme becomes unstable. Here we write a function code for 1D linear convection equation by using forward in time and backward in space. Here we write a main code for effect of grid size on a solution. Here we used grid points 40, 60, 80, 100 and 120. After running this program, we get the result. And here we observe that the peak velocity decreases for each time step and loses the square shape. And at 80 grid points, there is no decrease in peak velocity. At 100 grid points, we can see that the peak velocity again not decreases. So here we consider accurate square wave is formed. And at 120 grid points, the peak velocity blows up and gives unstable solution. In figure 6, we can see that the decreases in spatial grid size results in increases in code number. So in main code 2, this is the study of effect of time step size on solution. So for that, we have written the program and taken the different time step size, which is 1e minus 4, 1e minus 3, 1e minus 2, and 1e minus 1. And we get some plots which is representing the effect of time step size on solution. By observing the figure, the effect of the time step size on solution. First, for d is equal to 1e minus 1, which is representing the pink color, we observe that the velocity profile is not accurate solution. There is a lot of oscillation in profile. This time step solution shows most unstable solution. For d equal to 1 minus 2, which is representing the blue in color, the velocity profile is much close to the square profile to original curve, which makes it most stable solution and gives less error. For d is equal to 1e minus 3 and 1e minus 4, which is representing in green and red color, they both give almost same velocity profile, which shows the peak value of the velocity profile less than initial velocity profile, resulting less stable solution when compared with the 1e minus 2. From figure 2, as we can observe that as time step size dt increases, the value of code number increases linearly. And from figure 3, that time step size increases, the simulation time for a calculating numerical solution decreases. Conclusion: by solving wave equation using forward in time and backward in space, we are getting result that wave is moving from left side to right side. Also, we observe that by increasing the number of grid points, the shape of the wave is maintained. By decreasing the number of grid points, the wave loses its shape. Due to the presence of error is high, there is a numerical diffusion occurs. So we can conclude that the scheme is stable solution. By observing the results from program 2 and 3, the minimum velocity is less than the initial condition, and also maximum velocity is higher than the initial condition. That is what we are not expecting. That means our solution is not bounded, so this is called as solution blow. This occurring because here we are using second order approximation central scheme and first order approximation forward scheme on spatial derivative, but our scheme is not stable for this particular problem. So using a right scheme is very important for solving a computational fluid dynamic problems. From fourth program, as the special grid size decreases, the rate of decreases in peak velocity decreases, results in more accurate solution. Further decrease in grid size beyond a certain value, results solution becomes close up and become unstable. We can clearly see that from figure 6, the plot decreases in special grid size, results in increases in coordinate number. As coordinate number increases greater than 1, the solution becomes close up. According to the stability criteria, the best solution is obtained is for 100 grid points. For solution to be stable, time step must not be greater than the special grid size. From the program 5, the following result has been achieved. The larger the value of the time steps, lesser the accuracy of the result causing error. Lower the value of time step shows the velocity profile moves closer to initial profile and its shape, and peak value of the velocity but further decreases time steps, the solution gets unstable. 1e minus 2 is most stable and less time consuming time step compared to others. For a solution to be stable, time step must not be greater than the special grid size according to stability criteria. References: to get a clear knowledge about our project, we have taken references of some books and different websites, which is added below. Thank you.
Thank you so much. Question from our chair.
Hello.
Yes, sir.
Yeah. What is the application you are targeting? What application you are thinking of?
The application.
Yeah.
So to effect the grid size on the solution of the wave equations.
Can you repeat what you said, please?
So simulating the one-dimensional wave equation in MATLAB, assuming the initial velocity profile as a step function.
Okay. Can you give me one example of this wave equation in application? Any example of wave equation? Only
Presenters?
Yes.
Were you able to get the question?
Yes.
Okay, then it's fine. In last slide, you have written CFL. What is CFL?
Computational fluid dynamics.
Computational fluid
dynamics.
CFD. CFD or CFL?
So it's CFD.
Okay. I'll check. Okay. Thank you. Thank you.
Thank you, sir.
Thank you so much. And let me call on, oh, by the way, let me remind the remaining presenters to please proceed with your objective down to the main topic of your paper. Please skip the literature and the introduction. Let me call on the next presenter, which is the paper about design and investigation of braking system in a hovercraft prototype with full basic function by Sachin Chetty. Second call, the paper about design and investigation of braking system in a hovercraft prototype with full basic function by Sachin Chetty. All right, let me go on to the next paper about review on design and manufacturing of thermal heat storage tank using molten salt for CSP by Pankaj Janeshwar Chaudhary.
Yes, ma'am. I am here.
Hi,
Hello?
yes, I can hear you. Please share your screen.
Pankaj.
Bhushan, please share your screen.
Pankaj.
Yes, Pankaj.
Pankaj Bhushan. Am I audible to you?
Yes, you are audible, sir. Please.
Bhushan?
Yes, sir.
You have to finish your presentation within 5 to 6 minutes. Okay?
Okay, sir. If possible.
All right, go ahead and share your screen, please. Thank you. Proceed.
Hello, everyone. The topic of our research paper is design and manufacturing of thermal energy storage for concentrated solar power plant with uses of molten salt. We are the student of Department of Mechanical Engineering from Sandip Institute of Engineering and Management, Nashik. The author of these papers are myself, Pankaj Chaudhary, Vishal Bagad, Bhushan Borse, Vinayak Shevale, and Professor Sharad Bodke.
Bhushan.
Next.
Bhushan, your
These
slide
are
is not visible.
research paper.
Yes, sir.
Your slide is not visible.
Slide is not moving.
Yes, sir.
We use as reference for our.
Is moving, sir.
Okay.
It is pre-recorded video, no, sir.
Research paper and PowerPoint presentation. Now, introduction. Concentrated solar power plant is a power generation technology that uses mirror or lenses to concentrate the sun rays and in most of the today's CSP system to heat a fluid and produce.
Yes, sir.
Yeah, can you please share that PPT? What we are seeing is your file folder.
Okay, sir.
Your screen, on your screen, it is saying that only folders, not your presentation is seen.
Yes, please make sure that once you click on share screen, please choose the screen of your presentation. And please go directly to the objectives.
Now it is seen, sir.
Yes.
Yes.
I'll start from introduction.
Introduction. Concentrated solar power plant is a power generation technology that uses mirror or lenses to concentrate the sun rays and in most of the today's CSP system to heat a fluid and produce steam. The steam drives a turbine and generates power in the same way as conventional power plants. Other concepts are being explored and not all future CSP plant which will necessarily use a steam cycle. The innovative aspect of CSP is that it captures and concentrates the sun energy to produce heat required to generate electricity rather than using fossil fuel or nuclear reaction. Another attribute of CSP plant is that they can be equipped with thermal energy storage system using molten salt in order to generate electricity. If even when the sky is cloudy or after the sunset. This significantly increases the CSP capacity factor compared with solar photovoltaic, and more importantly enable the production of dissipation of electricity, which can be facilitate both grid integration and economical competitiveness. Next slide will explain by Bhushan Borse. Thank you.
Good morning, friends. My name is Bhushan Borse and I'm going to explain the types of thermal energy storage. This is one of the topic we taken from various research papers. We learned that research paper, and in that research papers, we think these are the potential types of the thermal energy storage types, like the sensible one, latent one, thermochemical one. But in the world around, there is abundantly only the sensible thermal energy storage is used. Latent thermal energy storage, lot of research is going on, and thermochemical system has more efficiency, but it degrades its capacity in very lesser time. Why we need thermal energy storage tank for the electricity generation in the concentrated solar power plant system? These are the problem statement we considered as a potential for our research paper. For electricity generation is not continuous. When we go for the photovoltaic cell, there is a lot of intermittent electricity generation when there is sun not available during the night session, and again there is a weather problem. That is why cloudy environment, and we cannot generate electricity, and for that purpose we need thermal energy storage tank. Whenever we have excess heat energy, we store in a thermal energy tank, and then it transfers to whenever we need. Whenever we think there is no heat supply, abundant heat supply from the sun, and we provide that excess of heat that we store in thermal tank for electricity generation. So it is for good for the grid management. Again, it cut down the load shedding, and it will also have good environment. And that is why we require thermal energy storage system. Problem statement are like design and fabrication of TES tank. In research paper we study about that. What are the different corrosion coatings we use to avoid the corrosion, and what kind of the shape we have to select for thermal energy storage tank. It will be underground or above the ground. It will be cylindrical, or it may be a concrete wall, or it may be a steel. So different type of the questions before going to research. And that is why we consider all that questions for our problem statement for preparation of the research paper. From the next slide, I want to invite our Vinayak Shavare for explaining further slides of PPT presentation of research paper.
Thank you, Bhushan. Now we are going to introduce the objective of the thermal energy storage tank. Lesser installation price than the photovoltaic cell. Then the one of the better option for the renewable and clean energy, which helps for the environment. Another is the replacement to this is the best replacement for the conventional thermal electric power plant. As my friend says that we can use this at the cloudy nature and at night time also. There is also this is also the advanced technology for the energy thermal energy storage using the molten salt. Use the electricity when the sun is not available and at bad weather like cloudy nature and rainy season. Then this is the economical system, good capacity. As we know that the concentrated solar power has the potential to meet the global energy demand, but the inherent intermediate is the main obstacle to the fulfilling this potential. To circumvent the issue, the thermal energy storage simple control.
Now I introduce the conclusion of this research paper. Concentrated solar power has the potential to meet global energy demand, but inherent intermittency is the main obstacle to fulfilling the potential circumstances ratio. Thermal energy storage is a sound option for continuous power production and shifting the solar energy of peak sunshine over to peak consumption. Molten salts are the most researched material for such storage. However, molten salt-based storage damages the environment as opposed to solid storage or PCM storage. The need for the however is to find more environmentally friendly materials and simpler design integrated with simple control systems. Last one is corrosion is another important issue associated with the molten salt, which reduces the lifespan of the CSP plants and hence the increased use cost. Thank you, friends.
Thank
Yes,
you.
sir. Presentation is over.
Yeah. Do you have any idea or any nearby installation you had visited?
No, sir. Presently, India doesn't have this kind of the installations, but United States of America in the Mississippi region, and again the Scandinavian country Sweden, and one of European country Spain, that installed the concentrated solar power plant as well as with the thermal energy storage tank.
Okay. So in India, what is stopping India in doing this thing?
Sir, India is the signatory of the Paris Agreement. India is focusing on renewable energy sector because thermal power plant energy mostly based on the coal system, and it makes pollution lot of in the environment. So India is focusing on non-renewable energy, and we think the concentrated solar power plant with the implementation of thermal energy storage tank will be the future of next India.
Yes, that's what I am asking you. What is stopping India?
In electricity generation?
Yeah, thermal storage tank and this kind of storage.
Yes, sir. Presently, thermal energy storage tank in the conventional way, and if we give for unconventional or renewable sector, it will be hydroelectric energy.
We couldn't go it. Okay, thank you.
Thank you. And let me go ahead and call in the next paper about the design and analysis of compact shredder machine used for recycling of face masks and medical additives by Piyush Jagdale.
Yes, ma'am, we are present.
Thank you. Please go ahead and share your screen.
Yeah, Himan, you share the screen.
Yep, I can see it now. Please proceed.
So good afternoon to one and all present here. Myself, the author Piyush Jagdale, going to present you the paper on design and analysis of compact shredder machine used for recycling of face mask and medical additive. So next slide. So we have been guided by Professor Amit Belwekar, who is a assistant professor at MIT Academy of Engineering, with his forefront research in stress analysis, finite element analysis, composites, solid mechanics. And next slide. So these are the authors and co-authors. Co-authors are Himani Chopde, Rutuja Devre, and Ekta Balme. Next. Okay, so moving on to the background. The ongoing COVID-19 disease significantly affected not only human health, it also affects the wealth of country's economy and everyday routine of human life. Thus, the production and usage of face masks has increased significantly as COVID-19 pandemic is progressing. Recent studies shows that 129 billion face masks are produced globally every month. That is 3 million a minute. Now the question arises what to do with this mask after its complete usage. So we have found out three methods: landfilling, shredding, and burning were the three solutions which we came to know about it. From this, shredding was the most user friendly. So we are currently working on the primary step for reducing the size of these masks and then reuse the fabric, which can be used for other purposes. Next slide. The mask collected is quarantined for the 4 days, and then the masks are grinded into small pieces and exposed to ultraviolet rays to kill the germs and infectant present. So taking into consideration these factors, we have successfully designed and analyzed the shredder machine and how this shredder machine can be used for other purposes. Next slide.
The design of the parts were made possible with the help of designing software like CATIA, and analysis is also carried out with the help of ANSYS software. The result obtained were matching with the analytical results which we calculated it analytically. Now the next will be explained by Ekta.
Yes, our system descriptions, in that we differentiate in three main domains. First is a machine construction, cutting systems, and then transmission system. The systems are distributed on the basis of the design point of view. Then the next is machine construction. In that it consists of blade, spur gear, bearing, nut bolt, and the frame of system, and the machine frame where all the components are to be assembled, and the selection of material for each component of the machine uh, we have done. Then the next we have done the analysis to check the system is safe for a required boundary condition. Then we go for the motor selection. This chart on the slide will be give a full specification of our system. First will be a name of system, fabric waste shredder machine. Next is a machine mechanism or the type of transmission system used, gear drive. Next is way of operating. Next is a processed. Next slide. On this slide, we give the information related to the system analytical calculations. In that, first we do the gear calculation because we use a gear drive mechanism. For that gear calculation, we select the material as a carbon steel 55 C8, and after that we get a result for the gear calculation as a module 2 and the gear ratio as 1:1. Then we go for the shaft calculation. For the shaft, we got a 20 mm diameter of the shaft. Then we go for the bearing selection. After bearing selection, we get a bearing as 6204. Next slide. After analytical calculation, we do the designing part. After calculation, we get the dimension of the shaft, gear, frames, and etc. components. We do the designing in the CATIA. First image shows the cutters, that is a shader gears. Second is shaft, spur gear, spacer, and bearing 6204 and the frame of our system. Next slide. We do the static structural analysis of gear. Static structural analysis is used to determine the stresses, forces in a component caused by the loading. In this static structural analysis is done on the ANSYS workbench. Steps for analysis is first we open the ANSYS workbench, then we double click on the static structural analysis solver, then we add the engineering material, then we import the geometry, then we go for the open the mechanical modeler. Then in that mechanical modeler, we first apply the material to the geometry. Then we go for the meshing, and the contact between the gear is the bounded contact between the gear. Then we go to apply the boundary conditions, we apply the fixed support at the whole surface of the gear A and B. Then we apply the momentum in anticlockwise direction as a 55.5 kilonewton mm. After that, we found out the results. The results are in this analysis. We found out that the results of from the ANSYS solver are closely matched with the analytical method, and the error in the results are from 0.01 to 0.1%. It is acceptable as per the standards. Next slide. This slide shows the fully working of our system. In that, first motor give the power to the shaft one, then shaft one will transfer the will give a power to gear one, then gear one will transfer the power to gear two. Then it will be rotate the shredder gears, and it will be rotate in opposite direction. It will be cut the face mask material in small pieces. In that we add the sterilized face mask material to the hopper. Then it will be cutting in the small pieces. Due to this shredder gear, then we get a small pieces. From that small pieces, we form some recycled product. As a further slide, they are explained by Piyush. Next slide.
Also, these are the applications of shredded fabrics. First one is the roads. A study was conducted with small amount of surgical face mask fabric was being mixed with 99% of RCA, that is recycled concrete aggregate. Then the second one is the eco bricks. So what are eco bricks? Eco bricks are the new concept of reducing and reusing the waste by filling empty bottles with the fabric, with the shredded fabric, and using those bottles for making playgrounds and innovative chairs. So these bricks are 3 times stronger than the conventional bricks, and it's its price. Third one is the cushions. The fabric of the reused shredded mass can be made into small chunks, and this fabric can be mixed with the cotton. The same concept can be used for the clothing by mixing the fabric with a certain ratio. Next slide. So the future scopes. As the machine in this case is a power-driven machine, more emphasis can be done on making a dual nature of by adding an additional feature of hand lever for a manual operation. Conveyor belt mechanism can be added to the machine at its hopper side. Grinding setup can be added to the grind the shredded waste and provide it for the further purposes. The concept of IoT can be used to make this machine less human operable. This machine can be optimized with the dustbins at hospital so that the face mask generated at the hospital can be reduced there itself. A provision of additional UV lights can be added for making more ease in sterilization of the face mask. Next slide. Now moving on to the conclusion, we have designed and analyzed the shredding machine. As the calculation was discussed by the ECTA, the results are closely matched with the analytical results, and it was easy to achieve the smooth working of the machine, and it's completely safe for the operator. The performance of the machine was quite adequate, and it gives proper chopping as per the requirement. The machine can be used for other industrial purpose also, where there is a requirement of shredding machines. Next slide. So these are the references. Some of the links are of the articles where we have found out the data, and some of the links were of the materials and other factors for the machine. So that's it. Thank you.
Thank you for your presentation. I will appreciate your selection of topic or selection of this paper, subject for this paper. But again, I will raise one question. How you are going to sterilize this mask?
First, we'll collect this mask and then we'll keep it for some 4 or 5 days at some place where the virus may get deactivated, and then we'll use this mask for other purposes. Or we can have a UV light where we can sterilize the mask in a box, or separate provision can also be made for it.
Okay. You manufactured prototype of this machine?
No, we haven't manufactured it, but we might manufacture it further on.
Okay. Thank you. Thank you.
Okay, thank you then.
Thank you so much. And yep, we're just waiting for other technical sessions to finish. And yeah, we will proceed with our valedictory function. But before that, let's go on a 5-minute break. See you in 5 minutes, guys.
Thank you. Thank you.
Welcome back, everyone. Hello. All right, welcome back. I hope all technical sessions are done. Right. Right now, I would like to take this opportunity to give thanks to all our session chairs, Dr. R.S. Chadari, Dr. V.N. Chauguli for technical session 1, for technical session 2, Dr. Y.L. Birud, and Dr. S.D. Kalpande. For technical session 3, Dr. N.M. Pawar and Dr. D.D. Ahiri. For technical session 4, Dr. Sampurnanandja and technical session 5, Dr. P.M. Yawalkar, Dr. D.V. Patil, and Dr. B.K. Verma. Thank you so much to all our session chairs who've attended and spared their valuable time with us. Now I would like to welcome HOD Mechanical, Sandip Institute of Engineering and Management. Let us welcome Professor Dr. Anil S. Dubey.
Thank you, madam.
I would also like to welcome the CEO of Technorec, Mr. Rudra Banu Satpathy.
Thank you very much, ma'am.
Thank you so much for your time, sirs. Oh, I would like to, let me check with my technical team. Hold on. And of course, this is also to thank all our keynote speakers from day one up to today. Thank you so much for their time and sharing their ideas with us. To all the presenters, the best paper for all departments will be posted on the conference website. I will be posting it on the chat box before we end the meeting. Don't you worry. I will be posting it again within 24 hours. So again, just to announce again, the best paper will be posted on the conference website, which I will be posting again on the chat box. And that the best paper within 24 hours. And that will be for all the departments on our technical sessions. Right? And I think that's about it for our conference. Thank you so much, guys, for your time. And in the website that I will be posting, any feedback that you may want to share, may it be negative or positive, you can just go ahead and share it on our feedback button. All right. So just give me a few seconds and I will be posting the link on our chat box. And also for the certificates, all downloads will be available on our website. Thank you so much again, guys, for your time. All the presenters, the professionals, our keynote speakers, and our session chairs. Thank you all for this conference success.
Hello.
अरे आगे कुछ अनाउंस नहीं कर रही क्या? This has been a remarkable conference. Indeed.
Hello, everyone. My apologies. Hi. Are you still there? Hi, everyone. Yeah. We will be. I will be welcoming back again. To provide a speech with us, guys. Hold on. All right. I welcome again to provide his speech the HOD Mechanical Sandip Institute of Engineering and Management, Professor Dr. Anil S. Dubey.
Thank you, madam.
My apologies, sir.
Very good afternoon to one and all. At the outset, first of all, I congratulate all the participants for their successful presentation in this conference. Indeed, this ICET 2021 has been a remarkable conference, and now we are on the brink of it. It was an enormous pleasure to be a part of it. In the last couple of days, 2 days, our well-versed researchers, the scholars, students, they share their knowledge, they share their ideas with the rest of people, those join our conference. When we look at the number, as we all know that this is one of the most successful conference because if you look at the number of registrations, the number of people, those presented the paper, those are more than 250. And managing those things. So it is possible just because of the participant, that your response and the technical team of Technocraft and the IFERP, that the care they have been taken. Now, when we look at this conference, right now we know that we all are going through a very pandemic situation and everybody is having so many other issues. But apart from that, still, if I look at the response we got for this conference, the people, those actively participated, it gives an energy to all of us, especially the organizing committee and my institute and IFERP, that this energy will be helpful for us for the preparation of the next conference. And at the last, I wish all the best for all the participants, and I express my thanks and gratitude to our management, Honorable Chairman Dr. Sandip Kumar Jha, that they had given the opportunity to organize that conference.
all the time they are motivating, supporting to us. I also thanks to IFERP team because they support a lot, and many time we have so many questions, so many queries with them, but all the time they provided the solutions and they are with us. Because of them only we are in position to conduct that, or the success of that conference is because of their support and help. I'm also thankful to the principal of our institute, Dr. Deepak Patil, my colleagues, the people. Those are, though I am here in front of you, but there is a one team, back-end team. Those are working very hard to make that conference is to be success. And that team includes Dr. L.K. Toke, Professor Ankit Mishra, Professor Prasad Kulkarni, and my entire mechanical department, that they are engaged in the preparation of that conference from last 6 months. Last year also we conducted one conference. That time we got the success, but when I compare with that conference, this is having a great or huge success. And I hope that in the next year also, in the same time, we will be there organizing the third session of that conference. So with this, I conclude my speech. Thanks to all. Once again, thanks to one and all. Thank you.
Thank you, sir.
Thank you, sir. Thank you so much for that speech. Now I would like to welcome the CEO of Technoret Group. Let us welcome Mr. Rudra Banu Satpathy. Sir, my apologies.
Thank you very much, Jozo, once again. So me and Dr. Anil Dubey, we both were wondering, why did Jozo left us in between? So, well, lighter note, it's okay. Sometimes it happens because of technical issues. A very good afternoon and a fantastic evening on this bright day, as well as at this pleasant evening. And it is really a privilege to speak once again on behalf of IFERP at this esteemed valedictory function to represent both the leading institutes, Sandip Groups of Institutions, Sandip Foundation, and IFERP Institute for Engineering Research and Publication. Well, our association with Sandip Foundation is not a new story. It has been more than, I think, couple of years. We are working together, and this is the second international conference we are organizing. And we are receiving overwhelming and fabulous response from different parts of country as well as Asia towards this conference. The event on which I was asked to speak was for the valedictory event. So basically, it includes a vote of thanks. So I will wind up my statements and my speech through few of thank you notes, but it's not possible to render my thank you message to everyone, because there are many stones behind the scene, those who have worked hard, and there are many leaders, professors and academicians from Sandip Foundation, as well as my entire team of IFERP, including Jozo, those who have taken leadership toward the successful execution of this conference. Well, let me begin this in a ascending order. So let me give a thanks to everyone associated with us in a descending order. Before that, and I'll like to speak few things about Nashik, the city from which we are streaming this conference. There are many speakers from other countries, other nations, and attendees, and all our team and members of IFERP, more than 50,000 plus professional members, the YouTube viewers, the channel subscribers, social media subscribers, as well as our professionals and student members, those who are watching from nook and corner of the globe. This conference is being streamed from city of Nashik, the holy capital, Nashik, that teaches everyone about the importance of brotherhood, importance of trust, importance of belief, the thought process and strength and priority of truth and dedication and respect, as well as importance of direction of an elder brother. Where I am speaking few things about the mythological tales of Ramayana, when Lord Lakshmana was directed by Lord Ram to take step and denaturalize Shrupanika. So this happened at Nashik in the bank of Godavari River. Everyone, I think almost all those who are a part of this conference knows this, but I felt this might be quite important and informative to know. And one of the holy capital of India, Nashik holds and organizes Kumbh Mela every 12 years, when the positions of stars of Jupiter and Sun strikes on same line. And Nashik is also important as per Delhi-Mumbai Industrial Corridor, with investment of more than $9 billion in last 5 years. And Nashik is also one of the leading producer of wine. I mean, 90% of production of wine comes from Nashik, as well as the agriculture production, the cloth industry, the fabrics. It is one of the industrial capital of India. Amid this pandemic, hosting this conference at a virtual mode was really a productive step, and this was done with support and instructions of faculties, professors of Sandip Foundation. At this point of time, I express my hearty gratitude to Dr. Guilio Manzoni, the owner and director, Microspace Singapore, Dr. Vijay Tharad, our frequent international speaker, and thank you, sir, for your esteemed talk, and it was really informative, Director of Operations and Corporate Professional Academy for Technical Training and Career Development, Dr. Razik Yukub, Associate Professor from Alabama area, United States, Dr. Liu, Managing Director on Circular Economy Accelerator. We have heard about many presentations, those who spoke about recycling economy, even how we can recycle the disposed masks and surgical equipments amid this COVID-19. So I think our students could be be sources of research and innovation, and they could be also get proper assistance in terms of funding if it is possible. Professor Safedan Kadri, Professor Mose Vade from Texas, United States, Honorable His Excellence Chairman of Sandip Foundation, Dr. Sandeep Kumar Jha. Thank you, sir, for this privilege to let us organize this conference in a very fantastic way. And my special thanks to Professor Dr. Deepak Patil, sir, for his support and the leadership and his direction to make this conference worthwhile of attending. And also my hearty thanks to Dr. Anil Dubey, co-convener of the conference. Getting response of more than 500 submission is really a fantastic number, is really a fabulous number, and more than 200 plus presentation is really a worthwhile attending of attending this conference. IFERP is committing continuous support and academic as well as scientific assistance towards Sandip Foundation, as we are already in conversation with the institutions. We are about to establish the institutional chapter of IFERP at Sandip Foundation that will assist the students and faculties of the institutions with great vision and thought processes. And together we'll be working along with Sandip Foundations at a rapid rate to globalize the innovative activities, to globalize the thought processes, the publications. You know, amid this pandemic time, India is thriving at a very rapid rate with about 6.7% of publication as per the index and statistics data. If we look at the pandemic period and we segregate them at 4 phases, I mean pre-pandemic or pre-COVID, and phase 1, phase 2, and phase 3. The pre-COVID was the period when the cases were detected in other countries, and few cases were detected in India. Now, when I'm talking of 2019, last as well as 2020 up to March or February period. So India had publications of 3.9 percentage of section of articles published in international forums and international journal. If accounted, that counts 2.7%. We move up to phase one of COVID-19, but the virtual platforms and some leading organizations, along with, I feel proud to say, IFERP, who has organized more than 200 plus virtual events amid this pandemic period. And we have associated with many universities and colleges, and we believe that education system and scientific knowledge propagation should not be interrupted. And my beloved colleagues starting working from their residences, their home, gave their best, and successfully we have organized a number of conferences in association with different universities of Asia and India. And successfully we have provided this privilege, and with this determination towards our scientific activities, again the number in second and third pages comes to 6.7% as well as 6.8% of contribution to world research knowledge sources and repositories. So even though India was among the top 7 COVID pandemic affected countries, still amid that, the universities and institutions of India produced approximately about 7% of research growth in global research forums. So this is not a bad number, and we are committing to all the institutions of Maharashtra and India, as well as other countries of Asia at a rapid rate. We are connecting with all the universities with a vision of globalizing the innovation, the dream of establishing the institutional chapters is behind the story of a big and a spectacular dream of establishing a common platform where institutions of different standard, different skills from countries like developing and developed countries can come together at a common forum, could share their knowledge, could learn from the research forums, could connect with proper professionals who can guide them, we can assist them, who can direct them with international opportunity to connect the researchers with agencies and organizations providing funds and grants to connect the researchers with the leading publishers, where the research papers could be published in the journals, Indexed Scopus or Web of Science. So these are the few commitments to the academic industry of India as well as globe. And we are insisting students and professionals to avail the benefits of the free membership of IFERP, where students and professionals get some benefits of our voyage and determination of globalizing the innovations, because we have some opportunities and scope for students and professionals to explore the opportunities and scope behind the available along with us. We also insist professionals, faculties and professors of industries and academia to join IFERP's professional membership. We have some scopes and benefits and opportunity of engagement. I mean, where the researchers can engage themselves and go beyond the campus life of universities. A student can also be benefited thinking beyond the classrooms, where the practical implementation and connectivity and scope of trials of these researchers they do along with industries could be availed at rapid rate. Simultaneously, with one hand, we are connecting with institutions, and in other hand, we are trying our level best to connect with industries and corporate sectors, where the students' research ideas could be brought to international forums and applications simultaneously we are looking for the agencies and organizations and institutions, as well as the corporates who are looking for the real opportunities of academics and the budding scopes and researches that is being developed at the grassroots level of the country. And we believe this gap of academic values and scientific understanding could be minimized to a certain extent with this type of activities like international conferences we do. And we are looking ahead for a very beautiful, fabulous, and fantastic relationship with Sandip Foundation. And I apologize personally with to everyone of the staffs, students, and colleagues of the institution for my absence for physical meetings. I have been invited by Dr. Dubey many times to campus, and I believe very soon I will be visiting the universities and meet my lovely and beloved students and faculties of Sandip Foundation face to face, and where we can imagine and dream for a better tomorrow with fabulous scientific and academic infrastructure where the research growth could be streamlined and progressed at a very rapid rate. I wish everyone a healthy and safe life, and I would request everyone to take vaccines and take all precautionary measures to stay safe. And thank you very much once again, everyone from the entire team of IFERP and Sandip Foundation, all organizing committee members. I apologize if I personally missed anyone to name them or address them. And obviously my lovely colleagues of IFERP and Technoarid Group, those who are very close to me in my heart. Thank you very much for your dedication. The conference coordinator Avinash, Venkateshwari, your leadership, the technical team, the backend team who works towards this conference, making all this arrangement, especially Jozo, you look very beautiful this evening. Thank you very much. And thank you very much. And I wish a healthy and safe life for everyone. Which says that all of us, irrespective of religion, irrespective of nation, irrespective of continent, irrespective of thoughts and belief, should stay safe. And our Sanatana Dharma, Hinduism, Hindu religion, and our country basically always pray to Almighty for safe and healthy life of everyone. Thank you very much. Wish you all the best.
Thank you so much, sir. I actually prepared for today. I apologize for my flaws, but I really did my best. All right, now to provide a vote of thanks, let us welcome from Sandip Foundation, Professor Prasad Kulkarni. Sir?
Thank you, madam. Good evening and all. It's my great pleasure to express a sense of gratitude and thanks on this really. First of all, I am very thankful and grateful to our Honorable Chairman, Dr. Sandip Kumar Jha, for allowing us to organize such a nice for us. I am grateful to Professor Pramod Karole and Professor Mohini Patil Madam for their kind cooperation and encouragement for the conference. Really, without great keynote speakers and session chairs, the conference cannot be successful. So we have great fortune that we have a very great keynote speaker as well as session chair. They grace the conference with their wisdom, knowledge, and guidance. And really, we are enough fortunate that we have such a keynote speaker and session chair. So I am really thankful to them all on behalf of ICETET 2021. I am thankful to Mr. Rudra, Mr. Siddharth for their kind support and cooperation to organize this conference in collaboration with IFERP. Without their collaboration, we cannot organize this conference. So I am very thankful to Rudra sir and Siddharth sir. Thank you. I am really thankful to our principal, Dr. Deepak Patil, for his encouragement, guidance, and kind support during the conference and outside the conference. The man behind this conference is Dr. Anil Dubey. So I am really grateful to you, sir. Your endless effort, guidance, cooperation, and support. We see during this conference, and from last 3 months, we are taking effort under your guidance, and day night you are working for this conference. So really, on behalf of ICETET, we are very much grateful to you, sir, Dr. Anil Dubey, sir. Then I am really thankful to my colleague and organizing committee members, because they are also taking day-night effort to make this conference successful. I am very much thankful to Dr. Anil Birud, Dr. L.K. Toke sir, and Professor A.K. Mishra for their kind cooperation, support, and endless effort to make this conference successful. I am very much thankful to all the deans, HODs of Sandip Institute of Engineering and Management for their support and kind cooperation. Lastly, I am thankful to all the hosts for their nice anchoring and entertainment during the conference. From last 2 days, we are observing this, that the anchoring is very good, and they are really taking effort to make the conference successful. And last but not the least, without participant, any event or conference cannot be successful. And this year we got an overwhelming response, not only from Maharashtra but across India and across the globe. We are getting the papers, and the participants are also there to present their research work at the virtual platform. So it is really an overwhelming response, and we are highly obliged with this overwhelming response, and we are very much grateful to all the participants who participated in this conference and present their research work. And lastly, I am thankful all the individuals who make this conference successful. Maybe some names may miss from my side, so I am apologize for that. But all efforts are from the organizing committee, co-convener sir, convener sir, coordinators, and the team IFERP. Also, I miss some names. Means Avinash sir. From last 4 months, we are in touch with Avinash sir, Venkateshwari madam, and Ranjan sir. So without them also, this conference cannot become successful. So I am really thankful to Avinash sir, Venkateshwari madam, Ranjan sir. So thank you all of you, and lastly I pray to God that keep all of us safe in this pandemic, and we please stay at home and be safe. Thank you, madam.
Thank you so much. Thank you so much for the vote of thanks.
One there, madam. The best paper from each stream and the overall best paper we will declare soon in recent 2 or 3 or coming 2 or 3 on the ICETET website only. Okay, so
yes,
3 days we will declare the result.
All right. Again, just to make it clear that we will announce the best paper to all departments on the conference website that was posted on the chat box. Right. I think that concludes our conference, and this I would like to take this opportunity to thank you guys for being cooperative and patient. Thank you so much for all your effort. And yes, may you have a great day, and yeah, rest well. Bye, guys.
नको करू.
रिकॉर्डिंग पान आपण सकाळपासूनची 93% वर वाढवली काय करत मी काय
कधीची आहे आजची आहे
कालची रेकॉर्डिंग आहे ती सकाळपासून टाकली सकाळ केला होता ना